pressure looks good.
Doubling up. Roger, roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight down, feed off. Bring in, feed off. Off.
Yikes. You bet. Concur. We don't need any more of these.
All right, folks, it is time for another bit of live stream coverage here today. We are standing by for test flight number 4 of the Stratolaunch ROC. I know y'all have been waiting very patiently in chat for us. Thank you so much as we were going through the flight preparations there, but we are starting the stream now. My name is John Galloway for NASASpaceflight. I'll be hosting the stream today. And really quickly, massive thanks to Stratolaunch for partnering with us so that we could bring you this coverage. Stratolaunch is actually covering some of the costs associated with today's stream. Also with me back in the studio today, we are going to have a familiar voice, Mr. Chris Gebhardt, Associate Managing Editor for NASASpaceflight. Chris, we got you on comms?
You do indeed, Das. How's it going this afternoon?
Well,
morning, depending on your time zone.
I've apparently called you an Associate Managing Editor, which is the first time I've ever said that. It's Assistant Managing Editor. I don't know if there's a difference, but thanks for joining us.
There really isn't. 601.
Excellent. Chris will be here providing some commentary today. And then also, we have a very special guest from Stratolaunch itself. Please welcome to the stream Mr. Mason Hutchison. Mason, thank you so much for joining us. How are you doing today?
I'm doing great. Thank you very much, John. I appreciate the opportunity to be here today. This is an exciting day of flight test lined up for us.
Outstanding. Mason is a principal mechanical engineer at Stratolaunch, and he'll be providing some technical commentary today. Mason, what does that mean, principal mechanical engineer? Like, you design this whole thing, you make sure the lights blink in the right order. What does that mean for us?
Well, it just kind of places the ability on an engineer to do a little bit of everything, to call them a principal mechanical engineer. It is mostly mechanical engineering, but with a little bit of economics maybe, and a little bit of mission planning for the parts. There's just a little bit more to it than just designing requirements and parts for those requirements. It's sometimes making some decisions on what the uses of those parts will be eventually. So it's kind of a cover everything type description.
Excellent. It sounds like you will be able to provide us with a lot of cool technical insight to what's happening today, and now might be a good time to start this. This is test flight 4 of the ROC. Of course, y'all, if you're not aware of what the ROC is, it is the largest aircraft in the world by wingspan. It's got a 385-foot wingspan that's 117 meters, and so it holds the record for the largest plane by wingspan. But it has a very specific mission that y'all are going for. And Mason, do you want to tell us, why did somebody take 2 airplanes and strap them together to make one larger airplane? What's the mission of the ROC here overall?
Oh, thank you. That's part of the most interesting thing about this vehicle. It is really the design of the 2 airplanes, what looks like 2 airplanes holding hands, we've been told, is really enables us to put the payload on the center line of the vehicle. That way we don't have any imbalance issues, and it allows us to put very large payloads. As you can tell, there's a lot of space between those fuselages. And at the same time, with the 6 engines and the large wing and the huge amount of surface area, this is made for picking up very heavy loads. Today's test in particular is being the 4th mission. This is more about expanding the test program, and the basic mission today is about cycling the landing gear. The first time ever, we'll be retracting all the landing gear in flight, which is what is very exciting about today. And along with that goes the landing gear doors at the same time. Some flight test steps that you do in there to make sure that the landing gear itself is operating properly and that the gear doors are operating properly. And we can talk about those when we start seeing that happen here soon once we take off.
Excellent. And y'all, that's why we've got the big area between the 2 fuselages there. We actually refer to the ROC as a carrier aircraft. and it's designed to hold a suspended payload between the two fuselages there. So you could strap something that you need to take up to a speed and an altitude to the sort of main wing in between the two fuselages and carry that to some place that it needs to go, and then release it or do tests on it or whatever. So ROC's primary goal is to carry things around up to specific speed and altitudes, correct?
That is correct, yes. And as a matter of fact, you don't see anything there now in between the fuselages and under the wing. The next flight test, you will. You'll see a pylon there in the next set of flights. That pylon is sitting in the hangar at this point. We're not ready to fly that just yet, but that is coming up soon and going to make this an actual carrier aircraft. Currently, the only thing the airplane is carrying is a human payload right now. It's the flight crew. There's no actual payload on the airplane as it sits.
Yeah. So again, folks, if you're just joining this, this is Stratolaunch. This is the ROC, a carrier aircraft. It is the 4th time ever that this plane has flown. So it says right up there in the corner, Test Flight 4. And we are expecting shortly for ROC to make a run down the runway here and see a little bit of a flight today. So you can see they've already pushed it back onto the runway. I have reports that they've already started up some engines here. They're continuing to go through all of those checks and all the preparations before they can fly. But very shortly here, I don't have an exact takeoff time, but I know that they are pushing to get this thing in the air so that they can run the tests that they're doing today. So Mason, let's talk a little bit more about the tests, right? We talked, there's no payload on it right now, but we still want to go flying. What are the goals of the test today? Like, why would you fly the plane if it doesn't have a payload?
Well, today we are testing the aircraft itself and the systems that are within just this aircraft. So that's why there's no payload today. The aircraft, as they come out of manufacture, go through a series of flight tests to test everything from handling qualities to systems, the way the systems execute their mission, all the way to even the materials and how they are interacting with the environment in which we're flying. Today, the systems that are mostly under test, like I mentioned before, are the landing gear. At times, there'll be other tests such as handling qualities, envelope expansion, and like envelope expansion would be, for an example, going a little bit faster and going a little bit higher in altitude. There is more of the failure modes of the systems that we're checking. So sometimes we intentionally will take a system offline to check how it operates in a reversionary mode. In this flight, probably not much of that, but a lot of the stuff that we cannot accomplish on the ground, we accomplish in the air, because always flight test is compressed. It's a little bit harder to test things in an open environment. It's more of a regimented test environment. So what we do is test everything we can on the ground first and then go fly. I'll divert just a little bit here and point out that you see smoke coming out of that number 6 engine. They are starting engines 1 and 6 right now. So that's
a normal thing.
Yep. So there are 6 engines total, and they're numbered left to right as you would view the airplane sitting in the pilot seat. So the number 1 engine will be the far left engine, and then count all the way over to number 6. We basically just started the outboard most engines.
All right. And they'll start, of course, all 6 engines before it's time to run down the runway, correct?
That's correct. The engines are started in sequence and brought online individually so they can be monitored for their performance and their systems that are attached to it. Engines have hydraulic pumps and electrical generation capability. So as they come online, we're connecting the electrical system together. We're connecting the hydraulics together, getting every engine, every pump to start participating as they should.
All right. And folks, like we do with our normal live streams, you can actually see some of the ground equipment going off the runway there. So that's a good sign, I would think. Like we do with our live streams, we love to answer your questions. If you're here and you're wondering what's going on, feel free to tag us in chat at NASASpaceflight. That will get your questions into some cool software here, and we'll pick some of those questions and ask them. They may be questions for Mason. They may be general questions about what's going on, but feel free to ask us. We want you to help. We want you to understand what the test is trying to do today.
And I actually have a question about some of the previous tests, Mason, if that's okay.
You bet.
Because you mentioned that, there's a large element of testing things on the ground, right? But there are things you just eventually have to get up and fly. So this is the fourth flight of the ROC carrier aircraft, but it's the first time, as you're saying, all the landing gear are being retracted. So what was tested on those previous flights, and why didn't the landing gear go up on the previous ones?
That's a great question. So this is being Flight 4 today. Flight 3 was a landing gear retraction, but it was the selective retraction of just a single landing gear. This airplane has a grand total of 8 landing gear, so 6 mains, 2 noses, one on each nose. And when you retract all the landing gear, you're taking some risk. Something could break, something may not come back down, something could happen that causes a system to go into a configuration that's undesirable. And we take small step approaches to that test. Therefore, in the last flight test, we only retracted 1 landing gear. If something should have happened, or if something did happen in that case, we would have been able to land. Not a desirable configuration to land in, but also not the end of the world for that. Today, they are testing the landing gear by retracting all 8 trucks at one time, retracting them at the same time. That's because we have done the ground testing and retracted them all as a series in a group. Here's something interesting about this gear retraction, though. We're unable to retract all the landing gear in the hangar at a single time. Just not enough hydraulic power by our ground power systems. Therefore, this flight is special because this will be the time that all the landing gear are commanded with one lever, brings all the landing gear up at once. This airplane has a tremendous amount of hydraulic production power, and it has therefore a lot of hydraulic fluid running around in the airplane, and that gives us the ability to retract, obviously, but we just can't replicate 6 engines worth of hydraulic power on the ground as easily as it sounds.
It looks like we're getting another engine startup there, right?
Yeah, that looks like the number 3, perhaps.
All right, 1, 2, 3. You said they were numbered left to right, right? Correct.
Numbered left to right. Yep.
All right. So again, if
engine 3 is starting.
Yep. Again, if you're just joining us, we are standing by for test flight number 4 on Stratolaunch's ROC, I guess I could say ridiculously large aircraft, the large carrier aircraft we see here on the runway. I don't know if I should call it ridiculous, but it's quite big. Let's put it that way. And
that's just fine. We call it ridiculous all the time.
Okay, good. Okay, that's good. We expect takeoff here shortly. So now is not the time to leave the stream and run off or anything like that because the engines are starting up. We've already seen the ground crews go off the runway. Are we expecting a chase plane today?
Absolutely. Chase plane is considered an essential part of the test today, and that's mostly because they are looking out for any issues of the landing gear. If you'll notice, the pilots' side that they sit on, they actually sit only in the right-hand fuselage. So on your screen, looking at it now, it's going to be on the left-hand side because we're looking at the nose. It's from all the numbering is from the perspective of the pilot, right? So they all sit in the right-hand side. They can't see their landing gear on their fuselage at all from the cockpit. And we have cameras around. They can select the cameras and watch them, but you can only watch one camera at a time. So that chase plane provides that vision of, are they clean? Are they dry? Is there a hydraulic leak? You can see hydraulic fluid on that white finish very easily. Look for streams of fluid or any kind of problems, any kind of mechanical issues, misalignments, things like that. The chase plane is a smaller jet. It's a Cessna Citation. There's the 2 pilots in it, and then there's a couple people in the back with cameras and another set of eyes just keeping an eye out for things, and they look for anything coming out of all over the ROC airplane, the carrier aircraft. That chase is considered an essential part of this flight test, and for most of the flight tests subsequently to this.
All right. So let's see here. On this one camera, again, if you saw us on the last stream, you know that we have this one camera here at the end of the runway. This is an unattended camera. This is a robotic camera that is remote controlled today by Michael Baylor here with NASASpaceflight. So when this takes off, it should come right at this camera. This is not a human-operated camera, though. We do not have a human sitting at the end of the runway here. And then we've also got part of the NASA spaceflight team out there operating various cameras today. Here we can see the view from Mr. Jack Beyer, who I believe is on comms with us now for a second. Jack, do we have you?
Heyo, I've been running around getting things set up, but things are set up now, so I can jump on comms and say, heyo, who's ready for some flight test?
We've got you at a little bit of a different angle today, it looks like. Where are you actually situated with your camera?
Yeah, this is actually Mason's idea. Great idea, Mason. Thank you for that. I take no credit. This is a view from on top of the control tower here at Mojave. So that is the angle you're looking at. ROC should go basically right by me and straight towards that other angle you're looking at. So hopefully we have some cool views of takeoff today for everybody.
Absolutely. It's such a great way to get a sense of scale here because right there between the two fuselages in the middle of the runway, there's a normal sized truck, right? And then you can see the size of the plane, the wingtips extending over the edge of the runway there with that normal sized truck in the middle of the runway. But Jack will be out there bringing us a feed. And we also have Pauline Acklin out in the field today. She is working on bringing us up a feed here as well. But we'll have all sorts of different angles to cover this takeoff, test flight, and landing here today. Let's see if we can't go over to a couple questions, I believe, because we've got some questions put in the queue. Here's a great one, Mason. How many people are on the flight crew?
I love that question. World's largest airplane, and the answer is probably one of the world's smallest crews. There are only 3 aboard this aircraft, and that's probably about as many as there ever will be. There's a pilot, there's a co-pilot, and then there is a flight engineer in the back. The pilot does all the normal pilot jobs that you would expect, and the same with the co-pilot. The flight engineer on this aircraft is a bit of a classical assignment for flight engineers. They monitor hydraulic systems, electrical systems, and in our case, they're going to also help monitor payload systems, which is a little bit different than your typical flight engineer. But our flight engineers have, in the way the mission is laid out for this airplane, they'll have the ability to, they have some time and the ability to manage the payloads as well.
Gotcha. So the huge plane and only 3 crew aboard. How does it work out? I think we talked about the pilot sitting on one side. Is it the pilot and co-pilot on one side, the flight engineer on the other? Is one of them just an empty fuselage with little fake painted on windows? Where does this crew actually sit?
That's right. The crew actually sits on the right-hand side only. They sit all together. The 2 pilots are in the front behind the windows. It's kind of hard to tell from this angle. Those are actually the windows from the 747. They were taken directly out of the 747, and we blended them into the shape of the nose of this airplane. And I think it was a fantastic job that they had done. The 2 cabins on the nose of each fuselage are identical. And that's one of my favorite interview questions for new engineers is why? Why would we have windows in the unoccupied left side of the fuselage? And I usually give them a little bit of time to answer, and they almost never come up with the right answer. Anyone here care to take a guess?
Oh,
Chris?
boy. Yeah, I love how you just instantly threw that to me.
I've been talking a lot.
Well, is it for situational awareness when you're carrying a payload?
No, actually, if I tell you that we built 3 cabins to begin with, that might help clue you in a little bit. We built the 2 cabins that you see here that are glued to the front of the airplane. The 3rd cabin we used in a test where we pressured it up and we ruptured it to validate our engineering and to make sure that it performed the way we estimated that it would. And it absolutely did. So now you have the idea, maybe we built 3 identical ones. It's an engineering reason. Guesses?
A structural spare in case.
There you go. Very close.
Yes.
That's basically the answer, and you would get the job, actually. Yeah. To clarify that just a little bit, the reason is we've done all the engineering on the one fuselage the one cabin that has the windows and all the pressure tolerating points in it. It shows that it can hold that pressure. So instead of redoing all that engineering on the on the left-hand side, we just put another identical cabin over there, and we don't have to redo any of that engineering. So it's almost a way of saving. It is a way of saving time and perhaps some money on the development of the airplane. That the left hand and the right hand cabins are identical structurally, and with the
Go ahead.
and
Sorry.
well, and the other cabin that was tested, we actually built four, as my memory serves me. The third cabin was built as a pressure test device. The fourth one is actually used in a simulator in our hangar that sort of looks and feels exactly like this aircraft. Our simulator is quite high fidelity for a program like
for that
this.
type of testing, right?
Yeah. So that offers the pilots the right perspective, the right feels and fits, with their helmets on. They'll actually fly with their helmets and things in place so that they can get an idea of where their windows are and that kind of stuff.
Yeah.
All right. Again, folks, we're grabbing some questions out of the queue. One of the things we do is we answer y'all's questions, the viewers' questions, as to what's going on. Chris, do you have a couple queued up you could grab us?
I do. One thing that we've got here is a question asking, what is the maximum elevation for ROC, and does payload affect the maximum elevation?
Those are great questions. There is not necessarily a maximum altitude, more than there is a maximum pressure altitude that we can go to. And of course, weight does affect that number. We have not been to that maximum altitude yet because there's some pressurization systems and some other reasons why we don't want to go there just yet, but we have gone on up to altitude. Today's flight goes to 22,000 feet, and what that is as you climb up in altitude, of course, you get your stall speed increases, and so your stall speed will also increase when your weight goes up. So there's a combination of altitude going up and weight being heavy, where you get to a point where it's kind of close to that stall speed. And because we're still early in the flight test program, we stay safely margined from that limit. The maximum altitudes are mostly for this shape of wing and this type of airplane. We're still in that sort of that airliner range. So right now we're only going to go to 22,000, but later we can probably do 30, 35, maybe 37,000 at times. It'll depend largely on the payload, and each and every flight will have probably a different limitation for the maximum altitude.
Fascinating. So sticking to today's test, like the part of what you were saying about like specific elevations and where you can go and what you can't do just yet. Let's talk a little bit more about the test today and what you will be doing. So if the objective today is testing the landing gear, Outdoor Man Show is wondering, will we have touch and go landings today, or will those retractions only be at altitude?
That's a aviation fan question. I would love to see a touch and go today, but no, that's not going to be in today's cards. Today's cards are just the aerial retraction and extension of the landing gear, and that'll be done at enough of an altitude that there's a good amount of time for recovery. If there's an issue, there's amount of time for assessment of the issue. That's really just a safety call to do it up at altitude. In the cards today are a couple of low approaches, however, and those are done for a couple of different reasons. In today's flight, we're going to do low approaches with the gear down. And that is mostly for the purpose of getting the procedure developed. Pilots get a chance to practice that approach, get their sight pictures practiced, because as you can tell, this is not something that we get to go out and practice in very much. And taking the opportunity to do that is always a good good part of flight test is taking those opportunities. Now a touch and go with this airplane is quite a bit more complicated than your typical airplane. Let's compare it to a general aviation airplane, something like a Cessna. They have a lot of room side to side on the runway. Our runway is 200 feet wide, and if they get a little bit off the center line, well, there's plenty of recovery space and things will stay safe. If you'll notice, we have 90 feet between our fuselages, therefore we don't have a lot of space left on that runway. So doing a touch and go may put this airplane at a little bit more risk than we're willing to take right now. Later, it'll be better because we'll have a lot more practice, a lot more understanding of our capabilities. However, it's still a complicated process. 28 tires spin up. 20. Let's do the math here. There's of the brakes, there's a brake on every wheel of the main gear, and there's no brakes on the nose gear. So brake temperatures, things like that, it complicates doing a touch and go. If your brakes get hot, then you have to wait for them to cool down before you attempt a landing, things like that. And rather than add that complexity to the test today, all we're trying to do is minimize the complexity and get a good, safe gear retraction. There's also some other objectives for today's test, which include some aero work, which is handling qualities and air data collection. One of the challenges of building an aircraft, any new aircraft of any size, is making sure that you have accurate data for your air. So what is our airspeed? What's our altitude? That way you know that you're in safe limits from a stall. You can stay in a safe flight regime. So we're continually evaluating that on every single flight. We have a set of maneuvers that we do to validate those. And like handling qualities might be, response to an control input in all three of the axes, pitch, roll, or yaw. And we're also doing some avionics testing today, which is always important because a lot of this aircraft is electronically instrumented. And we use an air data system. We use an external, like a
like an air data
experimental. Yeah, like an air data probe. But let's say we use an external one that's sort of experimental, that's more of a truth source, right? It's the pure, this is what it's truly the airspeed is, for example. And so the aircraft's airspeed measurement system, its pitot tube and its static air systems, we got to calibrate that. So we'll use this air data to calibrate the aircraft system, and then over time we gain our trust in the reliability of that airspeed indication system. Same for angle of attack, etc. We're also on board today is a yaw augmentation system, and we'll be testing that. And yaw augmentation is really what that is it's a damper. Probably one of the best examples for that is, imagine you're driving a car on a highway to highway speeds. They seem to stabilize when you kind of let go of the steering wheel in your lane. They don't depart from the lane necessarily. We have a yaw augmentation system kind of helps us do that. This long straight wing and sort of the shape of this aircraft means it has a little bit of a Dutch roll kind of effect on it. It wants to, the yaw, it has some adverse yaw issues, something like a long wingspan glider might have. So that's being tested. So it keeps it coordinated in banked turns. It will keep the yaw within a certain angle just to keep it running straight. Relative to the airflow, that is. And then, of course, we have some systems tests going on today. We're monitoring fuel temperature and pressure. 6 engines means we have a complicated fuel system. There's a lot of stuff going on with those fuel systems. So we are constantly taking data on that and improving that system as time goes along. And we're also adding more the fully finished systems as we go along. You kind of test as they go. Today, in today's flight, we have...
Sorry. So just for that part, is that sort of like you sort of just identify like, okay, well, we don't need this for flight 1, so let's not delay flight 1 because of something that's nice to have but we don't need, right? Like sort of along those lines. That's
exactly right. Exactly. And for us today, it's like fuel temperature issues are always a consideration when you have a high altitude aircraft. Jet fuel will turn into gel at a certain temperature, and you don't want that because it won't flow through pipes when it turns into a slushy mess. And what we're doing is we're making sure that what we estimated is our fuel temperature in the big giant tanks in there stays what we think it'll stay. So that's kind of a validation test. Also, the other 2 things we're doing today are cabin pressurization system and heating, because it gets cold up there and the pilots need to stay comfortable. And then we'll also do data collection on the aero systems like flutter. There's accelerometers around the airplane, so we check to make sure that like any vibrations we see, we can identify the source of that.
Is that the plane?
And I believe it's. I was just going to say, is that the spotter plane?
That is Chase. That's right. That is our Cessna Citation chase plane.
All right.
Is that the little brother plane? Like that's
It sits under in the hangar. It sits under the wing of the big brother. Yeah.
Yep. Storage is everything. Well, as we wait for Chase to finish the taxi here, good sign that things are progressing, right, Mason?
Yes, they are. In fact, we are through we're almost done with the pre-takeoff checklist. The pre-takeoff checklist of this aircraft is
Yeah.
long. It's 9 pages, and they do all kinds of different checks as they go along and sort of blend this. So as they near a certain spot on the checklist, they'll actually go ahead and deploy the chase plane so that they can go ahead and get to altitude, get established, and then they will loiter until the carrier aircraft is ready.
Excellent. And real quick,
nice.
folks, if you're just joining us here, you're wondering what's going on, you're looking at the ROC. It is Stratolaunch's aircraft, a carrier aircraft designed to carry payloads up to altitudes and speeds for testing purposes. And we are the NASA spaceflight team. We're not actual NASA here, but we're an independent media organization that is in partnership running the broadcast here with Stratolaunch today. So it looks like we are getting closer to an actual takeoff. Again, to reiterate, the small tiny plane there in the lower right, that is the chase plane, sort of a spotter plane that will be escorting the flight today. We expect it to take off first, so it rolling to the runway and turning will be a good sign. And then after that, shortly after that, we expect the ROC to roll down the runway and take off. So that's what we're doing. We're also taking live questions. Tag us in chat at NASASpaceflight, and that will get your question into a queue. And we are choosing some of the viewer questions to answer here. So,
And speaking of, I've got a couple more if we want to roll through them.
Excellent. Thanks, Chris.
Yeah. So Mason, earlier we were talking about the different the 2 fuselages, right? But the crew's only in one, specifically the cockpits. Sorry, not the fuselages. And we sort of talked about their history and everything there, but that sort of begged the question from someone watching. Are there crew members in both? Are they 2 fully functional? Like, if the left wasn't working, could you use the right on a test day? Or is one of them just kind of for aesthetics at this point?
That is the case. So one of them is entirely dedicated to the control and the operation of the airplane, and the other one is empty. It is an empty room in there. There's not a control panel. There's not an instrument panel. There's no control yokes. There are no pedals or seats even. And just as a fun aside, on the day of first flight, as a tradition, we get to engineers who work on it, which is me and my faithful team that I get to be a part of. We get the opportunity to fly a token of our own, or maybe even a little more tokens. They gave us an envelope, an empty envelope, and they said, whatever you can fit in this envelope will fly on first flight. We put that trunk of stuff, which go ahead and give engineers an empty envelope and say, whatever you can fit in there, you can fly. That's a comical response you get. You get a lot of cylindrical shaped envelopes. So I remember we put a trunk in that empty cabin on the left-hand side of the airplane, and we flew our mementos on that first flight. And then when it lands, we got them back. And now I have my favorite calculator has been flown on the first flight of the world's largest airplane. And that's a special thing for me. So that's really the only thing we've ever officially done with that left cabin is fly artifacts. And there's plenty of room to fly stuff in there. I think the intent for that was part of the original intent of why this aircraft was built.
Oh, you guessed the next question. Yes. You guessed the next question. Go for it. Yes.
Yeah, so the original intent of this aircraft is an aerial launch platform. So rather than launching a rocket from a stationary location on the ground pointed straight up like we're used to seeing, we're laying a rocket horizontal, and we're going to carry it to an advantageous location at a more advantageous altitude and drop it for it to launch from there. So you get a lot of that, a lot of the mass of the fuel itself of a rocket is dedicated to lifting it through that first low part of the atmosphere. Well, you get to save a lot of that mass if you give it the advantage of launching from, say, 30,000 feet or something like that. And also you get to go somewhere, such as over the ocean, where there are no people to be injured in case that payload doesn't operate right or that rocket doesn't operate correctly. So to perform experiments with rockets, it's a big advantage to be able to take it other places. And that's really what this is. It's not a new concept. The concept of carrier aircraft has been around for a long time. This is just another elaboration on it that got a little big.
It got a little big, yeah.
Yeah, and the size was driven by a particular rocket way back when, and I can't remember which one that was, but it was a pretty large rocket, and that we used that to size the aircraft. We changed the mission from that particular payload to another. I think at one time we had a trio of rockets underneath there, and then of course we've had a lot of fun in the engineering office putting all kinds of cartoon payloads on there and doing all kinds of things. You can use your imagination. So this aircraft was really, the intent of the design was to lift 550,000 pounds of payload, and for
Hey, so sorry about that. Quick thing that we worked, but we're back. Apologies for that. So Mason, I think you were saying right there that it is designed to carry a payload of 550,000 pounds?
That's correct, yes, and that would be about 250,000 kilograms, right?
Yes, indeed. Yes, indeed.
Yeah. So that was the original intent of the design, and that's the maximum payload that this thing would ever carry.
That's
and of
pretty
course,
impressive for a plane too.
That is quite impressive. Yes.
Yeah. And there are a couple of specific questions dealing with that. So we just talked about, a 550,000 pound or 250,000 kilogram payload there. What are some of the planned or anticipated payloads that it will carry? That's what one of our viewers is wondering.
Well, for us, the mission is confined to Stratolaunch's mission. So we're going to be flying the Talon hypersonic vehicle coming up soon. That is what we are developing towards. The next flight, you'll see an actual pylon hanging from the center line of the airplane right in the middle part of the wing in between the fuselage.
Ooh.
And that is specifically designed and built to carry the Talon hypersonic. And that's an unmanned hypersonic aircraft. And that is a small aircraft compared to the size of the carrier aircraft, in that the carrier aircraft is extremely overbuilt for that purpose. We recognize that, but the future is bright. Once we have that going, then we will be, we will be developing towards heavier payloads from there. Use your imagination. It could be a lot of different payloads going on here, from aerial test to, cargo. Mostly, though, we are focused on our mission as a company. Stratolaunch is going towards the hypersonic market with their Talon, and it is very well described on our website, stratolaunch.com.
And I want to sort of point out the visual here. We just had the the aero surfaces, and this is where I can only remember what they are called from the space shuttle, so my apologies. Not the ailerons? Is that what they are?
No, actually, what we saw go down and back up are the
those?
flaps.
Yeah. The flaps, there we go.
Those were the flaps, yep. And
you can tell Chris is a shuttle person.
Yes.
I can tell you're a shuttle person. Say elevons. Nice, Chris. Hey, we got to mention shuttle.
Yeah, my space plane knowledge kind of interfered with my airplane knowledge on that one. But I remember from the last stream that correct me if I'm wrong, Mason, but there are basically two positions: the one they're in now and the one we just saw them in. It's either like down or neutral, right?
That's absolutely right. Yep, those flaps are kind of a hybrid between a flap and a speed brake in a way. They don't necessarily produce any more lift. They are intended to produce a lot more drag and to kill the lift, because as you can tell, we've got a surplus of lift with this aircraft. It's got plenty of wing area. The problem with it is getting it down. So those flaps, they drop very extreme angles, and they're actually somewhat split. So they kind of, the trailing edge of the wing is kind of left behind. They're not like a traditional flap where they just tilt down. They actually have a lower surface that goes down, and the upper surface of the wing stays fixed. So they are what we call bang bang flaps, which is up or down. That's the only position you get. But we do have them built into segments. So there's 4 different zones of flaps, and they're symmetrical about the center line. So you can put out the outboard flaps or the inboard flaps, and it's just a combination of the number of flaps there that allow the pilots to have a bit of a choice in how much drag they produce. And right now they cycle those flaps to make sure that they work. It's like the pre-flight check. So if any of you out there are general aviation pilots, whenever you take to the taxiway and you're about to take off, it's always part of your pre-flight check to move the controls all the way side to side, up and down, check everything. Same with this aircraft, and the flaps are part of that.
Nice. And one question that I wanted to go back to, we just had that great visual, which is perfect time to talk about that. But a question that we have here from someone watching too regarding payloads as well, Mason. Musical was wanting to know, is there a payload test coming soon? And I know you mentioned the Talon, like the attach point, right? But what about payloads on that?
Yeah, so there is a payload test coming soon, and that will be the Talon, and that's slated to be later on this year. And it will be a captive carry test. So the very first thing we do with that payload is carry it captive and just see how it reacts, see how the aircraft flies with a payload. It'll be the first time it'll be flown with a payload, and that'll be part of that test, was to make sure that the presence of that Talon underneath the wing with its pylon that it's mounted to is still in the stable realm and safe, and that it doesn't vibrate or any problems with that. So just to point out,
my apologies for butchering the question, because that was sort of it. Talon is the payload and the pylon is what it attaches to. Right?
That's correct, yeah, and the pylon stays fixed. It's not a releasable pylon. So just to get back to what's happening on our screen now, you'll see that the nose landing gear lights are flashing, and what they're intended to do is flash alternatingly, what we call wigwag lights. And that means that the checklist has been complete and that we are now ready for chase to take off.
Ooh,
and so
that's
soon
seriously
you'll see
their
chase
name?
roll. That is their name. That's actually the industry name for alternating lights, is wigwag, and the switch says that.
I had no idea.
I did not either. That's awesome. But so speaking of the takeoff that we're about to see here, Mason, because we talked about a little bit earlier, right? You were talking about the dual fuselage design and how you can't actually line the fuselage that the crew is in with the center line of the runway, which is how aircraft normally land. So what aids are there for the crew to make sure that you're actually setting the center point of the aircraft down as close to the center line as you can, or following that center line in the case like we're about to see here?
That's a great question. Yes, you're off that center line by about 45 feet, and that is a different perspective. It very much is. So the pilots very quickly learn to point the nose in the right direction and put their fuselage in the right spot. But we did feel the need to put a bit of a visual marker on the runway. Now, airports around the world are standardized. Their striping is one way, and that's it. And that's for safety, and you want it that way. So we weren't allowed to put a new stripe on our runway. So rather, this runway has a repair that goes down the runway, and it's like a black car stripe where, like the sealing the gaps in a cracked surface. That goes right down the line where we need to have that right-hand fuselage touch down. So there is a black stripe that looks like a part of the pavement that is the visual marker for staying on that center line. And that is actually very helpful for the high-speed taxiing portion of the takeoff roll or the landing roll.
Nice. So admittedly, I wanted to ask that question before we asked this next one that's in our question queue here, coming from Patrick. So Patrick is specifically asking, how long is the runway at Mojave? But then I have a follow-up to that, but that's Patrick's question. So how long is the runway we're looking at here?
So this runway is 12,500 feet long. It's 200 feet wide, very standard-sized runway, capable of handling every large commercial aircraft, 747s, and anything near that, smaller than that. So 12,500 feet is our useful length of runway. We have a bit of a clearing on each end for because Mojave really is a flight test center, so they've cleared some safety buffer zone around the runways for other flight test programs and that kind of thing. But today's flight is calculated to only use about 6,500 feet of runway.
Okay. So my sort of different way of asking this question, so that sort of answers the question of how long a runway would need to be, right, for you, but how wide does it need to be, given the width of your aircraft?
I think if you ask the pilots, they'd say that this is the minimum width acceptable. So 200 feet is about the minimum width. Pilot
Gotcha.
and flight test programs, just about all flight tests that are for runway, for runway airplanes, maybe not float planes, but for fixed base airplanes like this, a 200-foot runway is usually generous, and that's plenty of space. So this one is a 200-foot wide runway, that is very generous. And then in this case, I think that the pilots are quite comfortable, but every flight test program has what is called a taxi test portion, and that's where the pilots actually evaluate the qualities of the ability of the steering to offset from the center line and come back and capture that center line again. And they're able to justify or basically judge the quality of control that they have and on the ground by how well they can recapture that center line. We call that maneuver the offset, capture, and hold maneuver. And you first offset from the center line at speed, and then you try to recapture that center line. And how hard was that task is the question we ask.
Ah, nice. Nice. So for those of you who are just joining, Mason, where are we right now? We noted a little bit when you said the wigwag lights were going on the ROC carrier aircraft, that meant that the checklist was done. So where sort of are we in the process right now?
We are at the point where we need chase to launch. So the next step will be the airborne pickup. Airborne pickup is where chase goes airborne first, and which was what we're seeing here, the Cessna Citation. And when they're airborne and everything is good, they will make sort of a low approach towards what would be the runway, but now there's our carrier aircraft sitting there on the runway, and they don't ever get down to the ground. They get very low, and it will release brakes on the carrier aircraft at the perfect time so that once the carrier aircraft is accelerated to flight speeds, both the base aircraft that's low but flying and the carrier aircraft that is just now to rotate, they're about matched. And these pilots are phenomenally good at doing this. There's a bit of a ballet for that maneuver, and that's called the aerial pickup, or the airborne pickup. And there's a pretty neat thing they do. The chase will call out 30 seconds, 10 seconds, and then they'll say brakes. And when they say brakes, that's when the carrier aircraft releases.
Nice.
There we go.
Chase is rolling. Here's Chase, yeah, right?
Here's Chase rolling, and this is just what we want. This is on time in the order of business, so.
Love the turbulence in this shot. I mean, we're looking right up the entire runway at Mojave, the big runway that the ROC uses, and we should get the chase coming right over us here in a second.
In Chase today, we have pilots Steve Rainey and Dean Spar. The controls of Chase. Two very experienced pilots, and they are going to climb out to a specific altitude and prepare for that airborne pickup. Also in Chase is Vanessa Rosenheim and Quentin Ganser as photographers, and also engineers on the program. And with them is Dominic Moen. He's our basically our PR specialist, one of our PR specialists, and he will be manning the cameras for getting these high-quality videos of that landing gear going up and down that we are all so anticipating.
All right, so again, that is a step in the process. We wanted to see the chase plane taking off. It's going to loiter in the area and sort of form up with the rock, but the next thing we should see is the rock start to roll. Rock start to roll. I can say that on air, right?
Oh, absolutely.
Has anybody ever said rock and roll when this thing takes off?
You know, that's new. No, yeah, we hear it all the time.
Oh, that's so original, Das. Well done. That's very original of you, right? I think last time the joke was when you smelled the exhaust go by, Jack was asking if anybody could smell what the rock was cooking.
I think that this loiter actually will be cut pretty short today because we did have a delay for our start time, and we're pushing to get into flight for the good weather. We have phenomenal weather in Mojave today. And by that, I mean good winds and clear skies and oh, they've already called 30 seconds for airborne pickup. So this is happening fast.
All right.
Oh, nice.
We'll start up close here so we can see when it starts to move out. But we should imminently get a takeoff of Test Flight 4 for Stratolaunch's ROC carrier aircraft here. This is a test flight where they are continuing to test the boundaries of the plane today. And like
That's
you just
correct.
said, about 30 seconds.
This is once they call 30 seconds, the carrier aircraft has pushed the power up to a almost takeoff power for engines 2 and 5, just those middle engines on each side. And that is for the purpose of having everything spooled and ready. Then Chase will call 10 seconds, and ROC will start to release brakes. And as they start their roll, they will push the throttles into their final positions.
It'll get loud here in a second.
Okay, we just cleared the 1,000-foot mark, and now Chase moves in close to do a down and dry check of the landing gear as it is now. We're not retracting the landing gear just off takeoff. We'll be up at altitude.
So question for those of us who are more familiar with space terms, down and dry. So down, landing gear down. I'm assuming dry.
That's correct. Dry is because we have so many hydraulic systems that retract the landing gear and the struts and the brakes. There's so much hydraulic fluid running around those, we look for leaks.
Ah.
Every function of the landing gear is powered by a hydraulic function. So everything from the dampers, the struts for the landing on the surface, to the brakes, the retract system.
A great view of all those landing gear there as well. They'll probably be much higher when they actually do the test, so I don't know that we'll have this specific view, but that was beautiful. That thing took right off.
It really was.
Mm-hmm. The target for the climb out is about 150 knots indicated, and there's a little bit of speed there, the band of air that they can be in, but they target 150 knots or so.
As the speed for takeoff, you said?
That's correct, and the climb.
The climb, gotcha.
Mm-hmm.
So sort of along those lines, Scott was wondering, how does wind speed affect the takeoff and the landing?
Oh, that's a great question. It depends on the direction. if the wind is directly in, you're flying directly into the wind, it just means that your ground speed is a little bit slower when the rotation off the runway happens and all that. But once you're airborne, doesn't really matter. It's airspeed. So the wind can affect maybe your ground speed only, but once you're flying, wind becomes kind of a non-issue.
Gotcha. So, so I like this question from Mike. Or sorry, I like this question from Vic. If there is a problem, can they access the opposite fuselage? But then what I love is that they added in the air to the end of that. So I think like, do you have access to the fuselage where people do not reside during the flights? And then in general, how accessible is that once you're in the air?
Yep, you would think that the world's largest aircraft by wingspan has that accessibility around the vehicle like that, but that is absolutely not the case. There's no access to any other portion of the airplane, a person in the air, once in the air. And the reason for that is the cabins are pressurized. So the fuselages are not. They are the same pressure as the exterior air. So in order to access those fuselages, you'd have to break that seal and relieve the cabin of its pressure. That simplified the design for us, and there's actually no need for a human to go to the other side or to access anything in the back of the airplane. We move all the controls to the front. So even like circuit breakers and things like that are in the cabin in the pilot side of the cabin.
Gotcha.
Mm-hmm. So no access. In fact, you cannot crawl through the wing. The wing is only about 5 feet thick. At one point in our build, there was the ability to crawl through the entire wing, but we've eventually closed that out by adding in fuel tanks and ribs and other structural pieces.
Yeah, fuel tanks would kind of prevent you from traversing, wouldn't it?
That's right. And then this system has 6 fuel tanks for 6 engines, and the left 3 do not communicate with the right 3. We can't cross-wing transfer fuel. We can transfer fuel only on the left side to the left 3 tanks, or the right side within its 3 tanks, but we don't transfer fuel from left to right.
Gotcha.
Or right to left, yeah.
Gotcha. So this kind of goes hand in hand. Another question that we have from one of the people watching is asking, what's the hardest engineering challenge when going into building a plane like this?
Oh, for us, there's many engineering challenges, but certainly the size. Most of the people who were involved in the build did experience a point in time where it felt like things were just so big they were unhandleable. And that never became the ultimate case. We always were able to figure it out. It just usually means you have to get bigger tools. But the size of this aircraft became our challenge. So that wing is quite high, and when we built it, it's built as a single piece wing. And the spars go from about the dihedral brake to the other side of the dihedral brake, and they were never separate pieces. They were always built as one piece. So it was built in place up in the hangar where it actually will live on the aircraft. So where the airplane parks in the hangar is approximately where it was built entirely.
Oh, wow. Wow.
Yeah, in fact, when we built the wing was the first thing we built, and the first thing we started of the build, and we had to build a platform high up in the air to then build the wing on top of that. And it was such a big platform that we had to have sprinklers underneath as if it were a building for fire safety and whatnot. But our fabricators, as amazing as they are, figured out a way to move their toolboxes and their gear up to that platform, and there were many days in which they would start their day going up on that platform, and the only other time they would come down was at the end of the day. We even had some break areas up there to take a break. It was massive, and it became very commonplace once the wing was developed enough to walk along it, and it became part of the room.
Oh, wow.
Chase plane up above on the right-hand split screen. Yeah.
That is cool. Speaking of the chase plane, so you mentioned the initial takeoff and climb, and we talked about the velocity that you're at when you do that. So whereabouts are they now? Like you mentioned there was a landing gear inspection. Do they kind of go up to a certain altitude, hang out there for that inspection, and then continue the climb?
I think in this case, I'm not actually sure if we do a climb with the gear. Yes, we do, I think. Yeah, so you do want to retract the landing gear, then there will be a climb and a descent. And a lot of that in our case, it will be for thermal aging, so get it a little colder.
Okay.
That's about the only reason. Let it, what we call cold soak. So up at 22,000 feet, it's cold up there, and it gives us an opportunity to get the hardware as cold as it's going to get, and then exercise it and see how well it works in that cold. And that's mostly because,
Yeah.
materials expand and contract with the change in temperature. So things that spin and slide will change how well they do that when they change temperature. And of course, we compensate for that with engineering techniques and choice of hardware. But you have to test for that too. We are actually getting to the part where we're going to do the first stable landing gear evaluation. So we are about ready to do a gear up, the first retraction of the flight.
Oh, that's amazing. So, and actually, that my previous question was leading to this one, which is, can we go over a little bit again, like what's the target altitude for today's flight, and what's the target airspeed for today?
That's a great question. So today's target altitude for this first step is 15,000. And we're going to want to target about 155 knots for the first test. And what we're doing is we can even go down as low as 130 knots or so with our flaps down. But the speed does go back up when the flaps go up. So for this this first test point, first gear retract, it'll be 15,000 and 155 knots. Later, we'll climb to 22,000 and do the same thing at 155 knots. And I think our fastest speed today is going to be in the 185 realm. And that's knots indicated airspeed, right? So when you climb, that indicated airspeed changes a little bit against what's really true, because as you climb, your air density gets a little less, your temperature changes, gets colder. So the amount of air pressure that's pushing on that pitot tube will change for a given speed. The airplane doesn't care how high altitude it is as long as it's getting enough flow over its wings. So that's why we go with an indicated airspeed system.
And so sort of another question that we've got here from Peter is asking, is there an airspeed limit for dropping the gear? So you mentioned that, one test would be at around 155, another up around 185. So yeah, can you talk a little bit about that?
Yeah, sure. So of course there's for bigger airplanes, there's two kinds of limits. There's a gear down limit, and then there's a gear operational limit, right? So that's the limit that's how fast can you be flying when the gear is in transit from being extended to fully retracted. For us, at gear extension speed, I'm actually looking for it on a chart because we write all this down on test cards. See, gear envelope is going to be probably that 185 is going to be the fastest gear down speed, and gear operation is 1. So you're about to do, so what we're getting close to, I'm being told what we're getting close to is that first gear retraction. So the gear handle is now being placed in the right spot, and they're getting prepared for that first retract.
We'll watch for the black dots to disappear from underneath the airplane.
That's right. Well, first let's watch for the flaps to come down. So the first gear retraction, we're going to go as slow as we can. So that means the flaps have to come down to slow the airplane as slow as we possibly can. Remember, with flight test, we're going to do start stepping in as gently as possible into this flight test plan. So we don't want to go out and try to retract the gear for the first time at the highest speed. We're going to do it at the slowest speed. So now their wings level, they're slowing the airplane down, and the flaps will come down soon.
Fantastic. And as we sort of wait to see that, another question here that we have regarding what you were saying a little while ago about the wing design for the craft. Are there any fuel tanks in the central portion of the wing?
There are not. We left that center part of the wing. Everything between the two fuselages there's no fuel in them whatsoever, and that was part of the design, for very intentional part of the design, mostly because when you have fuel in many places, it is a transfer problem. It can, more opportunities for leak. It just makes the system a lot more complex. And for us, one of the ways we were able to build this airplane in the period of time that we did was by simplifying the systems as much as possible. A lot of the systems and their components came from 747s, like donor airplanes, if you will. And those are complicated systems for, making aircraft that are commercially operated every day, many hours a day. And a lot of those systems have redundancy. They had the redundancies in place that we needed, but a lot of the system complexities we were able to eliminate because our mission doesn't require that. Did you know in a 747, the tail has a fuel tank in it? The horizontal stabilizer. Yes, this horizontal stabilizer in a 747 has, some of them do, have a fuel tank in there, and a lot of that is for management of the weight and balance during a long flight. So like some of those long haul flights, they will pump fuel back there to keep the airplane balanced in a nice primable position.
Oh, it makes sense.
Mm-hmm. So we, of course, didn't do that. We didn't want fuel clear back there because there's a lot of pipe that would have to be put in place to move it all the way back up to the engine. So we did not do that.
Gotcha. And as we continue to watch I believe the landing gear are retracted visually, it looks like. Wow. That happened quick.
Yeah.
I do not see the little black dots underneath it anymore.
So this is very fun for me to see. I've been on the project since the very beginning of the airplane build, and getting to see it flying clean like that is exciting. So I'd like to congratulate Stu Yun and his team for a successful deployment of the landing gear system. It took a tremendous amount of work to get 8 trucks to retract.
To be clear, this is the first time that this aircraft has ever done this. Brought all the landing gear up. Correct?
Yes, this is the first time.
Yeah.
And you said that, Mason, was that even on the ground? I believe earlier on you mentioned something about like you can't even cycle them all at the same time on the ground because of hydraulics.
Yes, that is true. When we're on the ground, we can't run the engines in the hangar. And when you retract the landing gear, the airplane has to be on jacks, right? So you could see that if you have engines running on jacks, that'd be a really bad situation. So we can't do that. Instead, we use what we call hydraulic mules, and they're these electric ground-based pumps that plug into the airplane, and they simulate the hydraulic engine pumps that each of the 6 engines have. And those electric mules, they just don't make a big enough capacity, enough throughput and flow rate capacity to retract all of our landing gear at once in the hangar. Therefore, they test one side at a time, and it's only in flight that we can retract all of them at once, which this is what makes this very exciting. Just would like to say congratulations to the test team for that. That's a big milestone to have the airplane flying clean.
Yeah.
Yep. So I do have a little bit of.
Oh, I'm sorry. I think we all excitedly had something to say. Yeah. Go ahead, Mason.
Yeah. No, I wanted to mention we did have a delayed takeoff today, so we had to modify the test cards. We're actually not going to climb up to 22,000. We're going to do just the low 15,000 foot test points, and which is kind of part of why we had to abbreviate and we had our delay. We had a plan to go up to 22,000, but we're only going to go to 15,000 feet today.
Gotcha.
This is really something to see with the ROC with its gear retracted for the first time like this. It looks so clean. I know that is the actual nomenclature clean, but no, it really looks super clean. And you mentioned Stu, Mason. In that awesome video you guys put out, I think was it yesterday on Twitter, I have a question about the landing gear that is now retracted. Stu mentioned something called an Oleo. That
Yeah.
absorbs the force of what is an Oleo? I've been around planes for a while, but that's one that has sort of escaped me. So I would love to know more.
Oh, that's funny. It's not the oil. Like I think there's an Oleo oil or something like that. But what an Oleo is there's a motorcycles kind of have something similar. There's that chrome strut of the landing gear that absorbs the impact of landing. So you see them when the airplane touches down, sort of the landing gear stroke, and it settles onto its landing gear. When that slides, that sliding portion of that landing gear is called the Oleo strut, or we call it Oleo for short. And it is just a fluid-filled damper that very carefully damps the motion of the airplane touching the runway.
And look at ROC coming back over here.
I gotta say, with the side shot, it sort of looks like two dolphins swimming next to each other.
Right? It looks like a good synchronized flying event in the Olympics.
Yeah,
Right?
it is. It should be a very well synchronized flying event because they're connected together.
It should be, yes, it should be. So Mason, a little earlier you mentioned that, immediately upon takeoff, the chase aircraft sort of did a visual sweep of the gear and everything you said down and dry. When the landing gear were retracted, what was the chase plane's duties in that moment?
That's a good question too. So the chase plane's going to move in a little bit tighter. They're going to take a look at the gaps in the doors. So the doors are painted white on the outside, and the gaps are left dark so that you can see from a distance if they're closed properly. Sometimes when you're flying fast and the airflow is moving fast, they'll pull one a little bit gapped or something like that. And the idea here is to check that all the rigging on the gear doors was done consistently and properly, and then they're looking for any problems that might have arisen. So also they're still looking to see if it's dry, right? You want to make sure that there's no streaks of red hydraulic fluid going down that white outer paint. So they're still checking for that, but mostly the observing pilot in the chase will be looking at each of the gear door gaps along the way, and then they keep an eye on the flight controls, such as the ailerons and the elevators, because keep in mind, even those are actuated by hydraulic actuators.
Oh, sweet. So a total curiosity question that popped into my head when you were saying that, Mason, about looking for the red hydraulic fluid on the white exterior. Is that one of the reasons white is the color? I mean, I know white has a lot of good thermal radiating properties and thermal stability properties, but is that another reason why it's white? Or is that just a bonus?
It's just a bonus. Yeah, the
Okay.
main reason it is white is for what you just mentioned. It's a thermal property issue. This airplane is, well, we think it's the world's largest single composite vehicle, like all composite vehicle. But that white color is to minimize the amount of heating done by the sun when it's sitting outside on the ramp. Of course, when it's flying, it stays pretty cool, but in this case, yeah, white is the universal color for carbon fiber aircraft.
That it is. So a little bit earlier, we had discussed we discussed how some 747s have a I'm so sorry. We had discussed how some 747s have an extra fuel tank in the vertical stabilizer to help with mass balancing properties throughout long flights. And we're getting a couple questions here about mass balancing properties in ROC. Because if the two fuselages aren't identical, how do you handle the mass differences between them? Is there a counterweight in the other one?
There is counterweight. Yeah, we call it ballast. And what it is on each of the noses, right at the very end of the nose in front of the pilots, under that what would be a radome, we don't have any kind of weather radar in there. We have mass. We have very specific weight plates that we put in for each flight. We tailor them to balance the aircraft. So it's partially a left to right balance, but it's mostly a forward to aft balance. The center of gravity forward to aft is our thing. The way the aircraft is built, it doesn't get very far out of balance left to right, and it flies maybe somewhat off of center line. It's not exactly perfect, But that's also an advantage of this shape of airplane, that it's tolerant of being a little bit out of left to right balance. But for the most part, it's pretty much the same with this airplane. It's a very left to right balanced airplane.
And if I understand it correctly, right, because the sort of the main way that the center of mass changes throughout this flight and the way that the plane is sort of designed is that the center of mass changes are sort of in the center of the vehicle to begin with, right? You're either draining the propellant tanks at very similar rates on either side of the wings, or you're dropping a payload from the center point. So is that how I'm understanding it correctly? Like, it's more about balancing the front to back, as you were saying, because the left to right sort of naturally evens itself out.
Yes, that is absolutely correct. The payload is on the center line, the CG, or because it's on the center line, it doesn't affect the left to right balance, but it does absolutely affect the fore to aft, the center of gravity location, which we shorten to CG. And our fuel tanks are very close to that CG, so as they drain the propellant, it drains in a nice linear fashion, and our CG doesn't change much. However, we do have an engineer on the scopes in the mission control room monitoring the fuel burn and thus the amount of weight, how much fuel is in the aircraft. Today we took off with a lot of fuel in the airplane. It feels like a lot of fuel, but it's pretty normal for us. See, I saw the number here earlier. We started today's flight with, I think it was, I get this right here. See, we are, actually, I don't know where it is. Oh, well, let's go back to the ballast question. For example, we have about 5,000 pounds of ballast in the left nose and about 2,900 pounds in the right nose, for example. So the left nose is a little bit heavier ballast because, right, there's a lot less systems, a whole lot less systems over there. And so we kind of pull that back over. Yeah. Oh, that's right. So today we took off with about 200,000 pounds of fuel. What would that be converted to in metric if we're at 200,000 pounds? We're about 91,000 kilograms of fuel. And we go by weight, fuel weight.
If you have a look, it looks like the gear have come back down again. Sorry to interrupt.
Hey. Oh, please. This is exciting.
And you can see too that the flaps are down, and you were mentioning to Mason that this is about controlling the airspeed during the gear retract and extension. Is that what they're called?
That's
gear
correct.
Retraction and extension, yeah.
And there is a single lever in the cockpit that is for gear retract and extension, and that's what they're operating to handle it, and that operates all the landing gear at once. So really the idea there is it is to simple gear up. You know, once this landing gear system is fully tested and operational, they'll take off, and part of the procedure is gear up, just like any airplane.
Nice. And again, for those of you who are joining us, this is the 4th test flight of the ROC carrier aircraft for Stratolaunch. And Mason, for some of our more spacey fans than plane fans, ROC is something we know of as like something a launch provider will ask the range, like for final clearance for liftoff. So ROC in this case has a very different meaning for you all, right?
Yes, very much so. ROC is our internal, I guess our internal program name for this airplane. And when we started building this 8 or 9 years ago, a good period of time ago, we name our programs an internal name that's something easy to use, usually single syllables, something that because we're going to be saying it a lot for the next several years. So we named this one ROC, and it is... It alludes to the it's a mythological bird that is in the story 1001 Nights. It's a legendary bird that just like the legendary bird that carried Sinbad the sailor to his adventures, ROC will carry our story protagonist, the Talon, to its high-speed adventures. We like to say.
Nice.
Yeah. Yeah, so it's kind of from that, right? And you can look up ROC, ROC and look at images, and you'll see two-headed mythological creature.
It worked out well for you.
Yeah, and I think in some images, I think in some images it even is carrying an elephant, which is always just one of those things that is fun to me because we got a question even that talks about how much stress can the wings handle.
Yes.
And that is related to me, it always sends my brain back, right? Because if that mythological creature carries an elephant, right? Well, we all know the concept of torque. So torque is amount of force at the end of an arm, right? So we like to use in the United States, we like to use foot-pounds of torque. And in other places, and around the world, they'll use Newton meters for torque. So if you're going to turn a wrench, then you're going to go to 100 foot-pounds. Well, the maximum bending moment, the maximum torque of the wing at its center line is approximately equivalent to a male African elephant weight of a male African elephant on a wrench or an arm a mile long. So we used to say 1 elephant mile of torque on that wing, which is a huge amount of torque, or what we call bending moment.
We usually don't put elephants on 1 mile long lever arms, correct?
Not usually, and you
Not a
can
normal
imagine,
thing.
yes, if you're trying to tighten a bolt with that much, that's going to be a seriously tight bolt.
Yeah.
All right, so
Real quick,
let's point out that we did have another gear retraction.
Yep.
Yeah.
Mm-hmm.
And I see this going through chat real quick, y'all. Just so you know, as the ROC gets a little bit further away from the camera positions here, you can actually track the position of the flight on Flight Radar 24. Head over to the website. It's ROC01, ROCC01. And you can see it's almost sort of running racetrack lines here around northeast of the airport. But as it gets further away from our cameras, you can keep an eye on where it's going over there on that website. But for now, we still have the views of it, so I'm going to make sure that they stay large on the screen like that.
And Mason, as we sort of go through today, how many of these retracts and extensions are planned?
Well, we did have a plan for several, and we had to modify the plan in order to get our test window complete today. So I'm actually not entirely sure how many total gear retractions and extensions we're going to have, but I do know that we're only going to do them down low. We do 2 types of gear extension and retraction tests. We do what's called stable gear evaluation. So that's the airplane's flying stable, no climb, no pitch, other than just staying nice and level, wings level. And we do a dynamic gear evaluation, and that's where you put the airplane in a wings level side slip or in a steady heading side slip and retract the gear. And that basically is to test the landing gear with some sort of side component to the relative airflow. Today, because we've had to abbreviate the test, I think we're going to eliminate the dynamic part of the gear evaluation, or at least some of that. It's really to inform us if there is any issues with the rigging of the gear doors, or if there's any vibrations or anything like that that we need to check out. Now, that also can mean, we need to retract and extend the gear in a banked turn, and that could be considered a dynamic test. And I think that's the one portion of that testing that we'll probably keep if we do, and that's a retract and extension of the gear in a banked turn. But still yet, there's a little bit of decision making on the fly for which of those test points we're going to do based on fuel burn and time remaining for the test window.
Gotcha. And so here's a question I absolutely love that's talking about the landing gear, but it's a callback to Flight 3. So earlier on, Mason, you said there's one lever in the cockpit that retracts or extends all the gear at the exact same time. So if that's true, how did you manage to only retract one gear last time?
Oh, that's a great question. Yeah. So what they're able to do is selectively, through design, assign that gear lever to specific landing gear if they need to. So they basically, just to simplify it, they wired it up to only a single landing gear. It's a little more complicated than that. They did have to do some thinking about what the safety implications of that are, and they had a few ways of, they put a secondary panel in that allowed the retraction of that one gear that basically duped the system, I guess, if you will, that says, okay, only that one gear is going to retract and the others stay down, but do so in a way where the system doesn't think the configuration has changed at all. And that's really how you would do flight test, for every system, is making sure that you don't get out of configuration for the intended test. An analog to that might be if you're going to test if you're going to test the opening and closing of a car door or something like that, you first try the one door at a time. You could test all 4 doors at once if you wanted to. But it's kind of starting like that is the reason why we do that. And in this case, that one landing gear handle is commanding all of the landing gear at once as it would normally. But yeah, we were able to still, because the pilots, we don't want to add workload to them. So if we start adding other controls outside of the normal expected controls, like the landing gear handle is very well known control to pilots. They know it even has a universal shape.
Right.
It has a little tire. The knob is actually the shape of a tire, which I love. I just think that's great. But we don't want to add workload to them by making them have to throw a different switch somewhere else. But we tend to try to make all the controls do what they need to do from their, from the normal expected controls. And that's just to keep the workload at a sensible place.
Yeah. Well, it makes sense. And like you said, like you don't want the pilots having to think of something that they're not used to.
Okay, so let's take
Yeah.
a look. The gear is about to come down, so let's watch it closely now. They're commanding gear down. At least they said they were going to put the gear down. Maybe Chase is getting into position for it. So as I see this, I am taking my information for the flight test from Grace Wang, and I'd like to tell her thank you very much for showing me this information and keeping me on track for what test card we're on. The flight test program is typically kept organized by a set of flight cards, we call them.
It does look like the gear down, by the way.
That
Yes,
pretty
it does
distant
look
on
like
that LRO,
yeah.
aren't we?
Sorry,
Yeah.
there, yeah.
Looks good though.
Looks great. I love how you said earlier, Mason, that something wasn't in the cards for today. And I know that's like an idiom, but also literally you organize things using test cards. So I had a chuckle, but I wasn't able to grab my mic fast enough to make that comment relevant. So I'm going to make it now when it's even less relevant. But yeah.
That's right. Yeah, it is literally a set of cards, and they're even sized so that you can strap them to your leg as a pilot. So the pilots have what we call a knee board, and these cards are just the right size where they can look down and read them and flip them as they go. And everyone is reading the same set of cards for consistency, and we can stay on track of what our test is, from the mission control room to the pilots on the ground. And I'm holding a set of those exact cards right now, looking at them, and that's how I'm able to tell what is coming up next. So they've got the gear down, and what they do is they put the gear down and they call for the chase to come in close and give us chase comments. And that is that, are they down and dry? Are the braces, what we call drag braces, and the links that move that landing gear, are they in their locked position? Meaning, do they look aligned and look like they're in a safe place, right? Because you can have a situation where a landing gear doesn't come down all the way, and the pilots would have some indication of that, but the chase is very quickly able to evaluate that condition if that were the case. But it looks like in this case, everything is happy and down and locked. Looks great.
That's absolutely fantastic to hear.
Yeah, I got to say, it is an absolute privilege working with a team like this. I am an engineer, and I'm just one of the many exceedingly capable engineers at this company. And we form friendships as engineers here because we've worked together for a long time. And many of us have been working on this for quite a long time, since its inception. And what we tend to do is we tend to get on a system as an engineer and sort of stay there. So, for example, I worked on flight controls for a good while. I've worked on landing gear for some time, and currently I'm working on the release system for the upcoming Talon pylon. And we tend to, as engineers, will stick with that portion of the airplane for it to its completion, because you end up becoming an expert in that system. So now we know of each other what our strengths are as we grow as engineers, and it becomes this sort of self-feeding, this self-perpetuating learning loop where we learn that, we go build something and we go test it and we learn from it, and then we learn from each other what we learned, in individual systems. It is probably the best way to educate yourself in engineering that there is. You can go to all the college classes and take all the courses you want, but there is nothing like the education that design, build, and test will give you. And in this case, we're at the end of that cycle where we're at the test part, and I feel very excited for Stu and his team. There's a magnificent fabrication team at this company, and it's a very tight-knit team, and that's just a lot of fun to be part of something. And when you see the landing gear coming up and down, that's the product of a great many people, including the management, that make sure that we stay on track and on time. And if you're interested in something like that, I got to put in a shameless plug here. Stratolaunch.com has some careers openings available, and it is so exciting to see what is available for jobs at Stratolaunch. We are looking for the best collaborative people that we can find, and I can tell you from the experience, I've been here since day one of Stratolaunch, and it is absolutely a privilege to get to be around these people, and it is so much fun. It's just something that is motivating every day. There's never the same day ever.
And that's what makes it so exciting, right? I mean, like when you push things forward, when it's all about innovation and how can we help the next advancement, right? Like it's fun when work is not the same thing every single day, right?
Yeah, exactly. And also too, I'm an engineer, so I kind of have that perspective, but there's many other great opportunities here, lots of fabrication opportunities. You don't necessarily have to be an aviation person to be productive or useful at this company. That doesn't necessarily make it a requirement. There are many people that work here that didn't come from an aviation background. I myself got a degree in mechanical engineering, and I missed out on some of the aerospace engineering that I should have taken, and now I kind of wish I had gotten an aerospace degree instead. But it's never been a limitation, because the opportunity to learn is so vast in an experience like this when you're building one-off proof of concept aircraft such as Talon. We're learning a lot, and the team that is building Talon is impressively capable, for the amount of information they're able to come up with on that. So it's just going to get more exciting from here.
I really like that you mentioned that, because a lot of times when we're watching a rocket or a vehicle or what have you on these streams, it should be driven home that all of the things that you see are the work of a large number of people putting in, basically, in a lot of cases, their life's work. And that time is spent well a lot of the time, and it's meaningful to call it out, because people spend long hours at work, people spend time away from their families, people pour their heart and soul into projects like this. And so that's one of the reasons, of course, why it's so great to see successful testing like this, is because it's very plain how much work and care is put into a vehicle and a flight test program such as this.
Oh, that is absolutely right. I call that the emotional paycheck, because on days like today, there's nothing but emotional paycheck. You get the satisfaction of seeing your designs at work and working properly. That it is probably the most satisfying possible thing that can happen in a career, be it engineering or anything else that it's involved with, an aerospace company, right? Engineering is just a part of that. There's facilities, there's upkeep. We have a big team that work on just keeping our builders building, right? For example, we have a huge support staff in our admins and that kind of stuff, that admins and our financial department, and it's just, it goes on and on, layer after layer of very incredible people, and you learn that you can trust them with things. It was fun. Last night we had a weather event in Tehachapi. We're in Mojave, California, and we're right at the base of the mountains, and some of us live up in those mountains. We got snow yesterday, so the team moved several of us down to a hotel last night to make sure that we didn't get caught in the snow and have to stay home with a road closure. And that's just spectacular that they can handle things on the fly like that. And that's really proves that you get a team that is, when you're on a team that has teamwork like that, it just gets really fun.
Super cool.
Exciting.
And I just want to stress again to everybody watching, this is the first time that ROC has ever flown with all of its gear up. Right now the gear is down, of course, but we've seen, I think, 2 retractions so far, and I'm so floored after having seen this plane fly now 4 times. It's the first time we've ever been able to see it fly clean like that, and what a sight! What an awesome sight and achievement.
And it really is an awesome sight to see in the sky, and to see us walk through these milestones. It really is, Mason. I mean,
It's
watching
such a
the
beautiful
team's
day.
hard work. Yeah. And watching that hard work pay off. Yeah.
Just that clear blue sky with the massive white plane in the middle of it. It is a sight to see, that's for sure.
And a few questions that we have here too. So Lori is wanting to know what engines are used on this. So you mentioned how much of the plane was sort of a new design and the challenges there, but what engines are being used on this one?
They're Pratt & Whitney somethings, right? What, PW 4000s?
Yep, they're in that family. They're 4056s, which are a common engine found on the 747, Pratt & Whitney 4056. And the systems and the pylons and the exterior cowlings and all that are directly from the 747. We did not build anything around those engines. In fact, those engines still have the thrust reversers on board. We don't use them, but they're still there. The facilities for those thrust reversers are there. They're locked out. So yeah, that is exactly right. And we utilize as much of the pylon that they mount to the wing on, the engine mount. We utilize as much of that as possible, because a lot of that was figured out. And when you're building a proof of concept aircraft, minimizing the amount of things you have to design is the name of the game. So that's really what we're trying to do all the time with anything we build. So you'll probably notice that we're no longer retracting, and we're doing that. We're actually I just found out we've completed all of the objectives for the day, for the test objectives, and we're going to be coming back for a landing shortly. So our test objectives are complete, and we'll be landing a little bit sooner than we expected. That's just because they were able to knock out those test objectives as needed.
Oh, sweet.
Mason, do you know if there is a low pass in the plan, or are we going to go straight into a landing here?
That I don't know, so I will find out for you.
You took the question right out of my mouth, Das. Thank you.
Yeah.
I'm
Yeah.
extremely curious.
And another question here is, as we prepare for landing and the return here, is the wingspan larger than the Spruce Goose? And I think this is where the interesting division between what do you consider largest comes in, right, Mason?
Well, I didn't quite hear that question. I was talking
Oh,
with Grace.
sorry.
Can you repeat that, please?
Checking. Of course, I
Yeah.
sure can. The question is the ROC wingspan larger than the Spruce Goose? And I said, I think this
Oh,
is where
yes.
how you define largest aircraft comes into play, right?
Yes, that is true. So we've got the Spruce. Actually, it's the Hercules. It's the H4 Hercules.
Yeah.
Howard Hughes never called it the Spruce Goose. The we are 65 feet big. I say we. Stratolaunch is 65 feet more wingspan than the Spruce Goose, right? Or the H4 Hercules. And because of that, it is the world's largest airplane by wingspan. However, when the wing was built and the airplane was basically done and we were out taxiing it, one of the interesting things that I learned that I didn't expect was we weren't called the world's largest airplane by wingspan until the day it flew. So we were out taxiing around this giant airplane, and you'd look it up on Wikipedia and it was not categorized as, and I asked about it, and that's just kind of a common thing. It's not considered the world's largest airplane until it's flown. And so the very first day, the very first flight, I'm particularly interested in the history of the Hercules and the Howard Hughes build. And the day it flew, we got a nod from the Spruce Goose Museum in Oregon, congratulating us for that first flight and basically changing all the signage in their museum from then on out.
That's nice. The note of congratulations must have been nice, though.
It was so great. In fact, they even worded it something like "tip of the hat," tip of the Howard Hughes hat, because I think he wore a fedora all the time. So that was very exciting to me. And during that first flight, of course, very emotional day for all of us engineers. It was nice to see that it flew higher, farther, longer, in every realm, every measurable aspect. But hey, so to honor that legacy of the Spruce Goose, we have lots of friends who have visited, and former engineers who worked on that Hercules. We have a couple of pieces of the Spruce Goose, stuck inside the airplane, attached to the inside, just as a little memento, a little nod of legacy to that, just as a fun thing. Not anything working or anything like that, just a little piece, because that airplane was made out of wood. And so,
sort of like how we took portions of the Wright Flyer to Mars with us.
Just like that, yeah. Just in that same spirit. Yep.
And okay, and I know you said we were approaching landing. Do we have an estimate or any update on that, Mason?
Yeah. So right now we are not sure if this is going to be a low approach or if this is going to be a full stop. That is at the pilot's discretion, and it always is. So I think in this case, we're just going to have to wait and see if they take it as a low approach. And what that means is they will fly the basic landing pattern and fly it fully, all the procedures and all that. They just won't touch down. Instead, they'll perform a go-around maneuver, which is just advancing the throttles and climbing out before they touch down on the runway. The pilots typically do prefer to do these low approaches because, like I said earlier, this is an opportunity to practice the landing, everything except the actual touching down. So what you're seeing now is they are at an altitude of approximately 7,600 feet, so they've dropped considerably. And that means that we're probably 10 to 15 minutes maybe from a low approach, if that's what they decide to do. We won't be able to tell they're going to do a low approach until probably the final approach, right when they are on final, very close.
That's what I was kind of wondering is when might we get the indication of which way they're going to go?
I think we've got to wait this one out, actually. I don't anticipate knowing. Yeah. So I'm not sure what the wind conditions are, but sometimes when you get late afternoon like this, we start to get maybe a crosswind push or a tailwind, maybe that kind of pushes the pilots to want to go ahead and get on the ground. Not sure.
It's quite windy up here in the tower, but I'm also way off the ground, so maybe not the best indicator, but the wind does seem to be picking up just a bit.
Just like any flight test or just a normal scheduled flight, everything that airplane does is under the command the pilot, they make the final call. So that's even in flight test, we have a control room and they're there to evaluate data and to suggest any kind of test configuration or to evaluate if the maneuver went right. But the safety calls are always left up to the pilots, and the ultimate command and control is always up to the pilots. Our mission control room is actually very fascinating. It's maybe about 10 to 12 people monitoring the different systems, and it looks very much like a modern day space like mission control room. Monitors in the front of the room, everybody sitting on their own station with headsets on, and they're able to communicate much like they did in classically, and it's a very, very neat setup, and it's very fun to see how they will interplay between each other when they do a test point. For example, a test point for a handling qualities test point might be we have to target an airspeed and an altitude. So the pilots will focus on doing that. Meanwhile, the hydraulics engineer is checking temperatures and making sure that's fine. They are just there to help that pilot out and to make sure that they're ready for that next test point. It's fun to see that collaboration between the two.
So what would Chase be doing right now?
Chase is, if they're on low approach, Chase is going to gain a little bit of distance from them. They're going to make sure that all of the gear are down and locked visually. Then that backs up what they're indicating in the cockpit. And they're also going to be looking for any other issues of the, like if did all the flaps come down? Is the airspace clear? Did the pilots in the carrier aircraft hear the proper message from the control tower? Because just like any other flight, this airplane has to call the tower and let them know they're going to be landing soon, and there's clearance on that, and there's also a lot of back and forth. They just use them as a double check mostly for everything, situational awareness. The Chase also is in touch with the mission control room, and they talk on what's called a hot mic. Therefore, the pilots don't have to worry about pressing a button to transmit a message back to the mission control room. And that is probably, so in Flight 3, that was my job. Grace Wang and I are both trading the job of narrating with you. And last time I listened to mission control, and I got to listen to that hot mic. And that's really informative, because as they fly, we will just say comments to each other that informs the control room more of, okay, we are on this test card, because you don't know you're on a certain test card, until everyone agrees that you're there. And sometimes, if you miss that one transmission from the mission control, then, you just kind of miss it out, and they don't know, you'll lose your spot for what card we're on. We have, and what's really cool is this airplane telemeters data down to that mission control room. So we are able to watch simultaneously the systems and the metrics of those systems, such as the engines and the hydraulics and the electrical system and the power production. 6 engines make a lot of electricity, and this airplane has an incredible electrical power system just that provides the main power across the whole airplane. And they have these different screens that they arrange that is as so wonderful to me. They're just full of tapes of data, everything from voltage to airspeed and all that. And you can build your own screen where you can kind of make your own control panel and watch whatever metric you want. So the person watching fuel system, for example, may also have an altimeter on their screen. And you might ask, well, what does an altitude need for the fuel system? Well, they're wanting to know what the altitude is, because they can tell what portion of the flight they're in, and their main concern is fuel burn, right? And so, do we need to climb more? Okay, I'm going to need more fuel. So they pick and choose what parameters they need to monitor in order to most safely keep watch over their systems. That really does make a complete picture. And what's even cooler about that is, after the flight's done, they can replay that data and pick and choose different parameters and watch it play along as if the flight's replaying in front of them. So it's almost like tape playback, right? And you can rewind and go back and look at that data. It's absolutely cool. And that data comes down by way of satellite transmission. So it's just like telecast, you shoots the data up to a satellite and back down to us.
Yeah, that was a great question because we talked about earlier. There's a crew of 3 on the plane, right? There's the 2 pilots, the pilot, co-pilot, and then the engineer. And it seems like a plane like this, especially once it starts to get missions, it starts to have payloads on the pylon in the middle. Seems like a lot for one flight engineer to monitor. So that's really interesting that they can actually send that live telemetry down to mission control, where there's entire other teams of people also watching what's going on with the plane.
Yeah, that's exactly right. And that's the purpose of that, is so that the engineer on the scopes on the ground, they can actually pull finer detail and get into some of the data that the pilots can't be tasked with right now, which, so for example, we have 6 engines, therefore we have 6 generators of electricity. If we lose one, the pilots may not even be able to tell sometimes, for example, and the engineer watching that will be able to monitor something, and they do power switching, they'll do data acquisition switching. So there's like a power production on the airplane, and then there's also data taking, right? So we've got sensors, thousands of sensors all over it, and for different things. So anyway,
once again, the sense of scale there with the chase plane.
Yeah.
I thought for sure that the chase plane was going to go behind it. Just the scale was messing with my eyes, and sure enough, the chase plane went, and it was between the camera and the plane there. Of course, we had some telephoto compression there, making it look like they were very close together. And from another angle here, you can see there is a fair amount of separation between the chase and the ROC.
Yeah, they do keep. It takes a lot of work to fly very close in tight formation. When you see aircraft in air shows flying real tight formation, that's a big workload on both pilots. Therefore, minimize that workload, you get a little bit of distance, and you've got some wiggle room there. It's kind of like driving on a highway. You don't want to drive too close to the other cars. You have to stay involved, and you can relax a little more if you fall back some and gain some safe space.
Gotcha. So a question here from one of our listeners, wondering, is there a reason why you're not flying with a mass simulator in the middle today?
Well, that is in the next flight test. As we're bringing the Talon online, we will be flying the Talon as kind of its own mass simulator at that point. So today is, because the focus is on the landing gear, we didn't want to put anything in that middle portion on that payload spot of the wing, just to keep the flight test simple for today. But that is actually on the next flight, so we'll see you then. That's going to be a very exciting flight too, because you'll have a visual change. You'll be able to see that pylon in that center wing. Actually, in the angle that you're seeing now, you see the flaps down. There's a gap in between the flaps in the middle portion of that wing, and that's for reasons. Reason for that is because the payload is right there, and we don't have flaps behind the payload, and that's kind of by intent. Yeah, the payload could be up close to the wing, or it could be down low. The various payloads that we've characterized to put there.
Gotcha. Real quick, I've seen a couple people ask about the voices that you're hearing real quick. So the voice you're hearing quite a bit with all the technical information is Mason Hutchison, who is the principal mechanical engineer for Stratolaunch, actually with Stratolaunch there. Mason, thank you so much for all the technical insight you've been providing.
Thank you for having me. I've really enjoyed being on today. I find this to be a big opportunity to share some of the experiences that I've had, and to also relate to you that we have a huge team here of very exceptional people, and I am just one small piece in a very large puzzle. And I got to give credit to the people I work with. The team that I'm on is just absolutely great.
Yep. And also, you've heard the voice of Chris Gebhardt, assistant managing editor for NASASpaceflight. He has been chatting a bit as well, but we also see the plane is approaching the runway here, it looks like. Let's see if it's going to touch down or not. Sorry, Chris.
No. All good. All good. Yeah, let's see if this is a practice or if this is our touchdown.
Yep. And then lastly, my name is John Galloway with NASASpaceflight here as well. But let's see what the ROC is going to do with the runway.
You see that nose down attitude, and the flaps are down, so that is a typical final approach configuration. Gear down, flaps down, nice and slow. Get the nose down, very stable.
You can actually see a little bit of the side slip there, I guess, which is the right terminology for that, but plane approaching the runway at a slight angle.
A little bit of side slip. Sometimes we call that crab angle.
Crab, thank you. Yeah. So at this point, Mason, do you call it? Is this a landing or is this?
No, I wouldn't even call it here yet. I don't think I could call that until we see actual tires on the ground.
And we talked last time about how you almost have to land 2 planes here. You get into a situation where one side touches down and the other side touches down. So let's see what the pilots decide. We are definitely
Looks like
well
they're
over the
going
runway.
back up.
So
Yeah.
that is definitely a go round. Yep.
Yep.
Excellent.
So so we sort of talked about, being able to practice that, get a sense of what the day of conditions are for your actual landing, right, Mason?
Yes, and that's part of the reason why low approaches are so valuable.
Yeah. So sort of start sticking with this, and you could kind of see it there as the from the different angles as ROC flew by. And you can see it right here in this view. One of the noses has a little thing protruding from the top of it, and the other does not. What are those, and why is it not on both sides?
Those are antenna, and they are there on the right-hand side because that's where most of the instrumentation is, right? So your radios, your altimeters, our radios transmit and receive over different transmitters and GPS antennas, for example, all your basic navigation equipment. And that is just to minimize the length of the antennas. If you run a wire up through that middle wing and over to the other side, for example, that's a really long ways, and no equipment that's available for use in aircraft are really designed to have that long of an antenna wire. So we kind of, for example, for the instruments that aid in navigation, such as GPS or radio navigation, those antennae have to be very close to the instrument itself. So that's why you'll see a lot more sensors on the outside of the the right-hand fuselage on that cabin, because that's where the pilots are.
Ah, gotcha.
That's also like an air data boom, right?
Yeah, so what's sticking out, it looks like a long sword for maybe like a joust or something like that. That is the air data boom. And that sticks way out in front of the airplane so that it's out in definitely, no question about it, clean air. That means that is the air that is undisturbed by the airplane itself, right? Because every vehicle, like a boat and an airplane, they have a bow wave, and they kind of push the air a little bit out of the way just in front of the airplane. And we didn't want to try to take that as airspeed data because it would be wrong. So we push that data boom way out in front, and it is guaranteed clean, nice air to measure for the airspeed and the altitude. Out there also on that boom are these little vanes that move with the direction of the relative airflow, so that they can tell precisely what the angle of attack is and their beta angle, which is the amount of yaw, or that crab angle we were talking about earlier. And you can tell if it's in any kind of side slip. Often you'll see on gliders, they'll have a yaw string for that purpose. And we've got a little instrument out there that is telling us that we are yawed one way or another. And we have those on the fuselage too, but we're using that test boom out front to make sure that we calibrate the ones on the airplane correctly. And that's also an item that gets monitored in the mission control room as, part of, did we get the right airspeed test point for measuring that air data, and making sure that those test points are complete by being at the right altitude, the right airspeed, and the right configuration, like the right position, attitude. So correct beta, correct alpha, kind of stuff. And I say beta and alpha, those are the names of the angles. Beta is for yaw, alpha is for angle of attack, so like pitch in that direction.
Gotcha. And
yeah.
Go ahead, Das. Yeah.
Well, I was going to say that it's actually kind of part of the nomenclature of our world here too. It's funny, as as the team builds these airplanes and we get used to what we're doing, we shorten everything we can. So we typically go around terms like alpha and beta just easily and fluidly, and sometimes we forget that the general audience doesn't use those terms.
And so, speaking of things that we sort of are used to / not used to, with a plane of this size, a couple people in who are watching the stream are wondering, why are the tails not joined together on ROC? It was more common on older twin fuselage planes. Is the question that we're being asked here.
Yeah, that's right. You see them in the old P-38 configurations. You see, you'll see them in many twin-boomed airplanes. Even Cessna had an airplane that did that. We actually studied that as an option. We wanted to put it together. We called it the Bronco tail. There is an airplane out there that's called the OV-10 Bronco, and it's an Army, I think, an Army observation platform. And they are conjoined at the very top of the vertical stabilizers up high. And we actually have a couple of configurations we looked at and studied. What it boiled down to was there is a very slight weight advantage to having two standard tails separately not conjoined. And it's just enough of an advantage that we decided to simplify our design by going with two standard tails sort of in a cruciform configuration, if you look at them straight on, sort of like a cross. And that's because it just had the slightest weight savings to the overall design. Also, we did a ton of concurrent design and build on this aircraft, meaning we knew what we were building, but we didn't know how we were going to design it. So as we were designing it, we were also building it. Well, at the same time that we were doing that, they were building the hangar, and pretty soon the hangar became the limitation because it was the pace of the hangar was a little bit different than the pace of when we built the tail in the plan. And we did those studies for quite a bit, and actually there's a lot of trades on those. It's not just weight, but there's some aero advantages. There's some system reliability advantages and that kind of thing. But it really did make it a much simpler. Just imagine, we built those tails on the ground where it's easy to access. You can stand on your feet and work on them. If we were to build the conjoined tails, that would be way up in the air, and now we have to build scaffolds, and it gets to even just considering what it would take to build a conjoined tail as one of the aspects in that trade, for example.
Gotcha. I mean, this whole plane just seems like a wonderfully fascinating engineering puzzle.
It is, and
regards.
I've given talks about it before, and I have this portion in one of my favorite talks it's called the KISS method. Keep it simple, stupid. And one of my favorite sayings in there is, don't reinvent the wheel if you don't have to. So that's why we have 747 landing gear, and we have 747 wheels and tires, and we use the hydraulic actuators from the 747. We saved a lot of design work and a lot of design time and build time by utilizing some of those systems.
Quite literally not reinventing the wheel.
Quite literally. It really is that. Here's another fun interview question then. Do you know why the sides of the fuselages are flat? And it's a very simple question.
Is it to minimize the airflow disturbance?
One would think it's all about aero, right? It's all about the aero, the aerodynamics of the aircraft. It's not. It's because you can build a flat panel on a table so much easier than you can build a curved panel. And so we took a little bit of, what are the disadvantages of having a flat-sided airplane, and we basically said, okay, what can we do to make this easy? And you'll notice there's a compromise. The noses kind of turn circular and become more of a cylindrical cone shape, I guess, conical, cylindrical-ish. And the sides stay kind of boxy. And they are panel built, they're panels that were done on flat tables just to make it a simple, quick build, and it worked really well.
It's exactly what you said. It's the simple ways, right?
Yeah.
I was going by. He said it sounds like a simple question. I said maybe for a principal mechanical engineer, it's a simple question.
Duly noted. Yeah.
So Mason, we kind of talked a little bit about what their options were here, and what do we understand about this next approach to the runway? Is it land, or is it low approach again?
This one does have the possibility that it's a low approach. There were 2 planned in the cards, and that means that there could be up to 2, but there will probably not be more than 2.
Gotcha.
That's
Yeah.
to
In
talk
fact,
about.
this is going to be a low approach with the option to go ahead and land. And that really what that is it's a sight picture thing. So
Yep.
the pilots will decide as they go. They actually think of it as a dress rehearsal. They are rehearsing an actual landing all the way to the point of deciding to go around. So
Right.
they speak to each other, they communicate in the cockpit. All their intentions are that of an actual landing, what we call a full stop landing. However, right at the point of decision height, they'll say either go around, or they won't say anything and they'll continue the landing. But go around is a very pointed term. It's a very, like we have a few words in the cockpit that are actually very important and they mean stuff.
Right.
And so go around is one of those. And what it is they manage the resources in the cockpit. So the pilot flying and the pilot not flying will share the workload in bringing the engines back up to power, making sure the airplane is stable, the speed is accelerating, and they'll climb out. And then also Chase helps them with that by listening to those calls on that hot mic I was talking about, and Mission Control follows along too, and they help evaluate the decision to go around or to proceed with going into a full stop landing. It's a beautiful orchestration of those three entities: the chase plane, the mission control room, and the pilots flying. And meanwhile, quietly in the back, the flight engineer is busy keeping an eye on the systems and configuring it for making sure that when they put the flaps down, that the hydraulics are good, and monitoring the pressures and the temperatures, and then watching brake temperatures once they do land, and for making sure that all the systems are still online for this.
Right. And that's an important point to make real quick. The fact that the ROC did a go-around, right? It didn't land on the first try. If you were on a commercial flight, you may think, oh gosh, we did a go-around. It's terrible. Something's wrong. But this is normal here. It's part of the test cards, like you said. It's a chance for the pilots to practice the approach in this massive airplane. This plane doesn't fly 50 times a day or anything like that.
Right.
So it's a great experience building time. It doesn't mean that anything went wrong or anything like that. Just a completely normal thing there with the go-around.
Absolutely right. Yeah, absolutely right. And that can happen even in the event, in a commercial flight as well. If something the pilot isn't satisfied with during that approach, they always carry the option to go around. And that is a safety call. That is a call to make sure that they don't proceed into something not so safe. And in our case, the mission control and the between the pilots, mission control, and the chase, they keep that scenario well characterized, and the go around really is a practice session for the pilots to get a good approach feel, get sight picture. Because remember, their practice is in a simulator for the most part, which is very high fidelity and very good for them, but this is the real deal, and having this flight time is very valuable.
Yep. And here we go, approaching the end of the runway here.
Will they land or go around is the question.
Yeah. So our pilot flying today is Mark Things, and he's known as Gidro. And co-pilot today is Evan Thomas, and flight engineer is Jake Riley. And together they are the flight test team that has they completed Flight 3, and now they're on Flight 4 in the same positions.
It looks like they're going to go around again since they're hovering down the runway there.
That is a go-around, yes. That is definitely a go-around, yep.
It's just floating over the runway. It looks sort of surreal, doesn't it?
Wow. I just have to say, I mean, after all this time of working on it, it just looks so great when it does that. I never get tired of that.
So as it sort of goes round again, and we were talking about aerodynamics, we were talking about the back tail structure, right, and why they weren't connected. And we've got another sort of wing aerodynamic structure question here, asking why do the wings not have winglets on the ends for improved efficiency?
Oh, well, that's interesting. Notice on those aircraft that do have those winglets, they are usually a swept wing configuration when they do that. This airplane has a straight wing configuration. It's what we affectionately refer to as a Hershey bar wing. And it's kind of that. It's supposed to be, more of a rectangular shape when looking at it from the top. This airplane has a straight wing, and it does actually have winglets. They're very, very small. And what those winglets do is it sort of trains the vortices shed from the wingtips into a more controlled, a little bit, less energetic vortex behind it, We're not so worried about that efficiency. I mean, we're running 6 engines, and they're not running even at full throttle. Fuel efficiency was not part of the mission of this aircraft, so we didn't really spend a whole lot of time changing the winglets and going for, you know, a fuel efficiency gains in any way. What we did want to do was have a wingtip that shed the vortices in a way that they were far away from the tails, and that they stayed in a safe area. So so there are actually, looking closely, there are tiny little winglets. They're kind of an upturn on the wing tip. And actually, you know, while we're speaking of that, if you notice that this wing has what's called polyhedral. So the middle portion where the 2 fuselages mount is straight. And then approximately 65 feet in from each wingtip is what's called a dihedral break, where the wing is actually kind of bent upward just a little bit. And that dihedral break is only, I think it's only about 3 degrees. It is part of what makes the stability of the airplane what it is. It helps with that, and therefore we don't need any more stability augmentation in that direction. It's a pretty basic wing design, and it was mostly selected for the ease of build. Building a swept wing, such as on an airliner, that's very difficult, and takes a lot more time. So this was a little simpler to build a straight wing.
Yeah, well, I mean, and it's interesting. I find myself getting lost in your answers sometimes, Mason, because I'm learning so much.
Oh, thank you.
About all of this. So I don't want you to take my oh wow, he's not saying anything. I'm digesting it, and I forget sometimes I have to talk. Because it is interesting, right? How different wing designs affect the aerodynamics and the stability. So things that you're just sort of used to seeing because that's how commercial aviation has developed don't apply to every single type of aircraft.
That's absolutely right, and we took a lot of our hardware from the 747, which is an operational commercial airliner that flies quite a bit faster than this aircraft here. But it wasn't for those reasons that we took those parts. We were looking for those because they fit the bill for the loads or the function of the airplane that we were looking for. For example, that landing gear they're all from 747s and from our donor aircraft, and therefore their retraction systems, like the hydraulics that move them up and down, they're all part of the original 747 application, and we just reused them in this. But the shape of the airplane itself is entirely unique. There's no portion of this airplane that on the exterior that is structurally from a 747.
So you mentioned the sort of the thing that the wheels are from the 747, right? That it wasn't a complete reinvention of everything, right? Just a tweaking of how things were used. And I'm wondering here, we've got another question too, sort of similar to what you would normally expect on an aircraft versus this. How many redundant flight computers are there? And are there multiple hydraulic systems as well?
Oh, that's interesting. That's kind of a question of redundancy, right? Because I mean, the flight control system on this airplane is direct input, so it's not a fly-by-wire. It wouldn't be like that of a very sophisticated fighter jet, right? Because that's just not necessary for this. There's inherent stability built into the design. It doesn't need to be compensated in stability by a computer system. However, you do want redundancy in the hydraulics because they're moved. The flight controls are moved by hydraulics. So you want to make sure that if one fails, you have the ability to still control the airplane. So that's exactly what there is. There are 4 independent hydraulic systems on the aircraft, and each of the actuators that are on the flight controls use 2 of those. So you can lose a hydraulic pump and the other one is redundant to it, for example. Or you can lose a system and you'll have other redundancies there. And that's very common to find in larger aircraft, that redundant system. And you can find them in even smaller, more commercial aircraft, like Part 91. But, Part 25, which is like a certain category of federally regulated aircraft. And we wanted that redundancy, and we understand our redundancies as part of the big picture overall for the safety of the airplane. And therefore, the electrical system has redundancy to it. Like I said before, the hydraulics, the computer systems in there. There are redundant computer systems that monitor positions and command a couple of things, but for the most part, it's a mechanical control system, and it has a lot of there is some servo action that happens, but they're more like a direct path kind of thing. So only redundancies in the system itself, but not really in the control. All the control is done by the pilots.
Gotcha. So as we sort of watch ROC continue on to turn to make its final approach here for what we anticipate is the landing this time, right, Mason?
That's correct. I believe so.
Talk to us a little bit about what's next for ROC. What's up next for it in its test campaign?
Well, anticipated to come up will be, within the next few flights will be the addition of a pylon in the center wing, and that will hold the Talon unmanned hypersonic vehicle that's anticipated by the end of the year. And that is what you're going to see visually happening in the next couple of flights. Sometime in the next few flights is that addition of that pylon.
Nice. And that's the one that we've talked about that sits directly between the two fuselages on the wing, right?
Yeah, that's correct. Yep. So the foreseeable future has this is what this is. This whole program and this flight test is building on the anticipation of getting a Talon on board, and we'll be doing, this is a test bed for that Talon mission.
Gotcha.
Yep. So the next attempt, just to go back to the flight here,
Yeah.
the attempt you'll see is going to be a full stop landing attempt. But as I said before, the pilots will have the option to go around if needed. So
Gotcha.
so they may choose to do that, and they always fly with enough fuel for those options to go around.
Yeah, it's a big plane. It's, like I said, it's almost like landing two planes at once that happen to be flying in a very tight formation.
Right,
So,
right. And we have so much gas available on board. So fuel levels right now are not an issue. This airplane is designed to go for many more hours than what is being flown in this particular test flight. So really, we are using fuel as a loading, kind of a loading fuel or a weight management device in a lot of cases. Yeah. So fuel burn is of no concern, although they do monitor it as if it were, just to make the flight go as safely as possible.
Right. There's no pylon, there's no payload, and it's got a massive payload capability, but none of those things are on right now. So you've loaded up plenty of fuel to make sure the plane weighs enough. It doesn't just float off. When it went over the runway last time, it looked like it was just hanging in the air. It was just floating above the runway.
Definitely part of it too. It might be that there's a good gust now. I would say maybe like 20-something knots. We got a good amount of wind, so they're flying into a headwind. So that might it's almost like a bird hanging out on an updraft. Like it definitely looked like it was hanging there for a second. And to your point, Mason, the pilot has discretion here, and you guys have plenty of fuel. So if he comes in for a landing attempt and goes around again, that's just in the name of safety, and everything is fine. That's totally to be, nothing to worry about. He'll put it down when he's good and ready, and we'll just have to sit here and wait. But I wouldn't mind a couple more low approaches if that's the case. But interesting. It'll be interesting to see this landing with a little bit of wind here.
Same here. Well, let's give a few props then to the pilot, Mark Giddings. Mark Gidrow Giddings. He's 22 years in the Air Force, and 12 of which he was a test pilot. And he's the one that's the pilot flying these landings, so he'll be doing the actual landing today. But next to him in the co-pilot seat is Evan Thomas. And Evan Thomas was the pilot on the first flight. He's our director of flight operations, and he's responsible for the safe and effective flight test and operational use of this aircraft. And they actually trade seats and share the job of the piloting job, because it's always best to have multiple strings of people. But Gidrow this morning it's absolutely fascinating for me as an engineer, because I love to attend the day of briefings and the day before briefings, and I like listening to him because he has a way of recounting or going through what the test is going to be like, and it's really nice. He has over 6,000 hours in over 50 types of aircraft, and 2,000 of those hours is as a flight instructor. So
Oh,
I
wow.
mean, everything. The list goes on and on, from 737s to all kinds of military aircraft, which just are fun. B-52 is one of my favorite ones that he's rated in, and he flies big airplanes as well, and helicopters and gliders and all kinds of stuff. But
Very cool.
these pilots are seriously qualified, even have patents, and Gidro has patents and that kind of thing. But also, flight engineer is very qualified for that job. That is a big job. That even requires a rating to be a flight engineer, which is something that's kind of unusual nowadays, because most airliners don't use a flight engineer anymore. But there still is the need for flight engineers in some aircraft platforms, especially this one.
If I'm not mistaken, is this the first flight that Evan has not flown, and as the pilot, and instead this will be the first time?
No, actually, this is the same as Flight 3, so he was in the same seat in Flight 3. Mm-hmm.
Excellent. Is a component of that like training up a second pilot to be able to have the skills to fly as sort of the lead?
Absolutely, yes. Both pilots. It's kind of funny how they call it pilot and co-pilot, and really we don't, as a company, as a team, we don't really label it that way. We have pilot flying and pilot not flying, and that means that they can swap the jobs just the same and have the same responsibilities. So the pilot flying is the one with their hands on the wheel and their feet on the pedals, and the pilot not flying just is the one that's not doing that, but they're doing other things, and they will swap back and forth during the flight. I think what we've got here coming up is the actual landing. Let's see if we get this one is going to be the landing, I think. Of course, they would have the option to go around.
So Jack's camera here is on the tower, and the plane is almost pointed right at the tower as it approached there. Then it's straightening it out.
Looks like they decided to go around again.
He just called to go around. It's about a 10 to 12 minute cycle time for a go around. So the pattern is pretty large, and it's not a very fast airplane, so they'll take a little bit. It'll be about 10 minutes for the next attempt.
Next attempt.
That's all totally normal, and that doesn't mean anything's wrong at all. That is absolutely a normal part of flight test to do a go around.
Yep.
Indeed. But so sort of sticking with this, because we were just talking about the distinctions that you both do and do not make, right, between your pilots. But what about the training for the pilots? Did you all have to build your own flight sim for training, given the uniqueness of this aircraft?
Yes, absolutely. So I would first like to acknowledge that that question came from the Academy of Model Aeronautics. I am a model airplane
Yes.
aficionado my whole life, and I actually credit model aviation to my career. So,
Oh, nice.
so yeah. So anyway, thank you for that from the Academy of Model Aeronautics. The flight sim that we have is a unique build entirely, and that's because the systems on this airplane are entirely different. We utilized as much of the interior portions of the cockpit of the 747 as we could. So like the instrument panel is pretty much the same thing, and like the pedals and the yoke and the seats and all that we took directly from the 747. So we took the opportunity to make a simulator just the same, and we've got this simulator in a room that's a fixed base simulator. So the floor and the nose of the airplane is sort of represented, but it's fixed. It doesn't move. And outside the windows of that simulator is this semi-hemispherical screen where cameras point to it, and they show the exterior portion. So they actually kind of give you that. As you're sitting in the simulator, you actually get kind of the feelings. Your inner ear doesn't do anything, but your brain is like, wow, it feels like you're rolling and turning, and it feels like everything is there. And in fact, I've had many chances to learn how to fly this airplane by getting in that simulator and landing it and and doing takeoffs and such. And it is really great because the systems are represented. So you flip a switch and the gear goes, you flip the gear handle up, for example, and you look out over that left fuselage and you'll see the graphic of the landing gear retracting. How cool is that? And so there is it is really interesting how that simulator does, even though it's fixed, you sit in it and you roll and turn and you feel like you're moving. The brain just puts you there. It is high fidelity in my opinion. I'm sure there are some other systems in it that could be better represented, but for the most part, anything that's critical, they do it all. And what's really great about our simulation is that it's connected to our mission control room. So it practices the mission control team and the flight crew team just the same, because you have to practice the mission control jobs and the responsibilities at each scope. You have to practice those just the same as pilots would go practice in the airplane. You need to have the communications and the ability to judge what the system is doing and if it's in a good configuration or not. And so they commonly have what we call sim session days, and those sim session days include the entire team of the mission control and the flight crew in the simulator in 2 separate buildings. It's really cool how they tie it together electronically, and it looks like a real flight. It is they even have radio calls in it, just like a real flight. It's absolutely fascinating. Those that are fans of flight simulation games, eat your heart out. It's awesome.
You see people posting up pictures of their home simulator, right? And they have all these screens and stuff. You should just post up a picture of the big simulator.
Oh yes, yes. It is absolutely great stuff. So much fun to fly.
Yeah. So folks, if you're just joining us, the huge aircraft you see in the air is the ROC. It's the Stratolaunch carrier aircraft designed to do testing of things that need to be carried up into the air, various hypersonics and things like that. The plane has a lot of capabilities and a lot of cargo capability. And today they performed a couple tests for the first time ever, retracting all of the landing gear. On Flight 3, they actually retracted a subset of landing gear, but not all of the landing gear. So today, in Flight 4, we saw earlier, a couple times for the first time, the ROC flying clean, no landing gear protruding from the bottom of the vehicle, the airplane there. And now we've seen a couple of go-arounds. You can actually see from our cameras that the winds have been picking up as we progress into the afternoon here. Again, always at the pilot's discretion whether or not to land. Like Mason was saying, plenty of fuel here to go around, but we continue to watch them basically get some experience in flying this massive aircraft out there at Mojave today. Mason, thank you so much for all the insight, all the technical information. Folks, Mason is with Stratolaunch. He's a principal mechanical engineer with Stratolaunch there, providing us some fantastic, not only technical insight today, but a team insight. Some of the things and the way that you feel when you see these tests proceeding and the gear retracting and flying clean for the first time. Thank you so much, Mason.
Thank you so much, and I have had a great time with you. This has been a really good experience, and of course a great flight test. And as I mentioned before, the emotional paycheck from a good flight test is always worth it, and happy to share it. Really happy that Stratolaunch has taken the position of letting this go out on the public airwaves, and I'd like to give a shout out to our CEO and our CTO. Our CEO is Dr. Zachary Crever. Our CTO is Dr. Danny Millman. And those guys are absolutely instrumental in helping us set up what we want to make as our public image, which is that of flight test and solution making. So I just want to thank those guys for being such a great leaders and helping us get to a great flight test today.
Couldn't agree more. Thank you so much to everybody at Stratolaunch and for allowing this to be such a public thing, because flight test is so cool. It's the bleeding edge of technology and of human knowledge, and we're expanding that envelope of human knowledge today, and you guys are sharing that with us. And so I know I'm biased because we're the ones bringing the feed out to everybody, so of course I'm going to be appreciated, but absolutely I think it's the right thing to do, and it's super cool that you guys are open to this, and I'm just floored that we're able to partner with y'all and do a stream like this. So thanks.
And one thing I really appreciate about Mason is I can hear the enthusiasm and the love that you all have for this, and that's part of what we all love to bring, is not just I mean, certainly the technicality of what is going on, but that drive and that passion from the people who make it possible. So thank you for helping to bring that from the entire Strato team.
Oh, thank you so much. Thank you.
Yeah. And folks, if you want to keep up with what Strato is doing, some of our mods have put a couple links in chat. You can follow Stratolaunch on Twitter. It's twitter.com/Stratolaunch. Pretty straightforward. Click on the link there and toss a follow over their Twitter. We are you typically get some announcements and things that are going on. Of course, what's going on today as well. But hop on over to Twitter if you're a Twitter user and toss a follow to Stratolaunch.
And
yeah, there's that
Mason,
link again.
Yeah, as they sort of roll around here to realign with the field, we've got a question here asking specifically to you, addressed specifically to Mason. Since the standard 747 is 2 engines per wing, is the innermost engine mounted on the spare pylon that comes on a 747 that was intended for engine transport? And I hope you understand that, because I think I got it. But
yeah, this is great. This is one of my friends. Thank you, Rich. Yeah, the 747 has a mysterious 5th pylon, right? They all have 4 engines, but occasionally you'll see a picture, and you can actually Google this, the 747 5th engine. And what that is there's a mount for ferrying an engine. And it's when they do that, it's not plugged in, it's not running, it's not consuming fuel or making thrust, it's just along for the ride. And what I think they used that for was transporting an engine from one airport to another on a regularly scheduled commercial flight. And that is they can take the engine off of, for example, send an engine to an airplane that needs one in some other place, and they could do that without interrupting a flight schedule, perhaps. And so no, for our airplane, we didn't actually use that mounting position at all. We just used the regular pylons for the 4 normal engines. But that 5th pylon is one of the oddities of the 747 that I am always fascinated by. The design of that 747 is absolutely spectacular, and that is one of the neat little niche curiosities that they have. So thank you for the question, Rich.
I think at the time, like when the 747 was debuted, there was no real easy way to transport something as big as one of its engines, except, hey, why not transport it on the thing that already carries the engines? It's a really nifty design decision. And it makes sense that you guys wouldn't utilize that, because your wing is not a 747 wing. It's a completely different in-house designed, one-off wing for ROC, not like a modified 747 wing or anything like that.
Yeah, that's correct. And structurally, we just didn't need that 5th pylon at all, that 5th mount. But we did use the same pylons, and we built our own structure on the inside of the wing that accepts that original Boeing pylon. So that makes it nice too, because if we have spare engines too, because we bought 2 747s and we stripped their parts and used what we could from them. So therefore, we have a couple of spare engines in the hangar, because they come with 4 each.
I think somebody could do the math for us on that. How many engines could the ROC ferry if it needed to ferry engines? It could carry quite a few engines, I bet.
Oh, I love those pictures. Yeah, those Photoshop edits
Photoshop.
like that.
Yeah. Like 15 engines on the pylon in the middle of the 2 fuselages.
Yes. Yeah.
So 2 fuselages, which is great. So Mike Hancock is asking, so does that mean that the simulator has an extra cockpit to one side?
Oh, that's funny. It doesn't in reality, but it does graphically. So it's just the one cockpit in a room, but you look out over there, and I don't know how the people that we've had several simulator engineers work on this, because it's a big project, but they somehow added that nose to the graphic in the cockpit, and as you're flying along, it stays right there, and gear up, and the landing gear will retract and gear down, and it'll deploy. But the best part of it is you can release the payload and launch the payload, and it drops and flies out in front of you and climbs up and away. So that is really fun to see that in the simulator. You can take off, like just me, I'm not a pilot, so I I don't know if they put it on easy mode or what for me, but I'll take off and right over the mountains. I'll just hit release and see what happens. We've had the opportunity to do that, and that's a lot of fun. It's just so cool to see the graphics kind of play out to what our intention is. And
yep, I want to point this out
that.
really quickly here. This is the runway cam. It's actually situated at the end of the runway, and you can see the crabbing there, how the fuselages are not pointed right down the runway. And if we look at Jack, who's on the tower, the two fuselages are almost pointed directly at Jack, who is on the tower off the side of the runway as it crabs in on this approach. I'm using the terminology there correct, right, Mason? Crabs in
You
on the
absolutely are. Yes,
Say that?
that sounds great. And they're just compensating for a little bit of a crosswind.
Yep.
And as they near the surface of the runway, they'll correct it and lay it down straight and smooth on the runway.
All right, let's see if we get some engine noise here once again as we make another pass for landing. We've got smoke on both sets of landing gear there.
It was a beautiful landing.
And the ROC has touched down out there at the Mojave Airnespace port.
I love the bit of clapping and cheering that you could hear in the background too. That always, I love the ambiance that adds to everything.
Yep.
Oh, congratulations, test team, for making such a great test flight today. It looks very successful. And that cheering is coming from the rest of the team that is getting to watch, because they also get to participate in watching. You know, our company believes fully in that emotional paycheck idea that I was talking about. So we actually set up viewing areas for our employees to enjoy watching the fruits of their labor. And wow, is it rewarding.
That landing looked like butter. Like, wow, there was a crosswind and everything. It's been gusting like crazy up here at the top of the tower, and that landing looked
My sentiments exactly.
nice and easy.
Even we talked last time about how sometimes one set of gear will touch down before the other set, and I'm sure if you roll back the tape and you look at it, clearly one touched before the other, but the two clouds of smoke were almost together, right? It looked like the whole thing just sort of down to the runway.
Well, there's a lot of wheels that have to spin up, and because sometimes there's a little bit of angle of attack, the aftmost, the rearmost wheels will spin up a little bit ahead of the forward ones.
Yep.
But that's by design, and that is absolutely normal. And also the trucks, the individual wheels, they tilt, you know, like the 747. So you'll actually spin up the back two, and then they'll lay down, and the front two will spin up for each of the trucks. But that appeared to be a very good landing and very good centerline performance. So very excellent. Congratulations, Ivan and Gidro and Jake. Very good job.
Here, Jackie
also,
is actually zoomed in, and this is actually the side of the plane that the flight crew is on, correct?
That is correct, and that just under that window there's kind of a square shape. The outline on the top there, just under that is their cabin door. So it's kind of a little round door. That's what they get in and out of. So what they'll do here is they'll sit for a little bit, and they'll monitor engine temperatures, and they're doing a shutdown procedure so that the ground crew can approach and check on wheel temps and get ready to tow back.
Oh no, that's interesting. Wheel temperatures. Can you talk a little bit more about that? Why is that something that you'd be interested in?
Well, that is something we want to be interested in, because that is what our limitation, that wheel temperature or brake temperatures are, you know, we're trying to stop a very big, heavy object, and we don't want those brakes to overheat. But also we're using it, we know through math that the brakes will heat up to a certain level, a certain temperature, if they're operating properly. So that is a measurement of how well they operate, and it works really good. So they just monitor those temperatures to validate their math.
Oh, nice.
Mm-hmm.
So Mason, I guess we've got the ROC back on the ground here. You can see the truck is actually approached it, like you said, going through all their checklists to safe the vehicle. When would we expect to hear from Stratolaunch on the results of today's test?
Well, later on today, they will be giving a press conference, and they will have be handing out the information that talks about exactly how successful the flight test was. Of course, me sitting here listening to the hot mic and the help from Grace that I've had today, we're not actually able to tell how well the test points were performed. That's something that we do in post-processing and data analysis in the days to follow. So we do take several days to kind of evaluate what all this data. It's an unbelievable amount of data that gets streamed from, that's stored from these flights, and they're used for a variety of things. So we take a few days to evaluate that and measure just exactly how it went. Sometimes it'll mean that we go retest something, and sometimes it means that we're good and it concludes the test. So it just depends. But for this one today, we'll get kind of a qualitative assessment of the flight from the crew later on this afternoon. And you can expect that in a formal press conference release and our social media releases as they come out. They will be making comments on that.
Absolutely makes sense. And like we said, folks, you can follow at Stratolaunch there over on Twitter, I know, is one place. And as they do releases and things like that, that is a place that you could find that information. But I do believe here with the ROC back safely on the ground out there at Mojave, let's one more time go around the horn and just talk about the voices that you were hearing today, starting with you, Mason. Of course, we had Mason Hutchison, who is the principal mechanical engineer with Stratolaunch. Thank you so much for being with us today. All the insights you gave us, just absolutely fantastic to have you here, Mason.
Oh, thank you for having me. I've had a great time. I very much appreciate it. John, Chris, thank you.
Outstanding. It's one thing for us to sort of sit here and sort of talk about what we're seeing as the third party, you know, NASASpaceflight here, but it's so good to have somebody from the company who can provide that insight to us. It really does add a lot to the stream. And chat, if y'all are over there, if you're viewing right now, say thanks to Mason for us. He did take time out of his day here to join us and help us understand what was going on. Also, back in the studio, we had Mr. Chris Gebhardt. Chris is the assistant managing editor for NASASpaceflight. Chris, thank you so much for adding your voice into the mix here today.
My pleasure. Just like Jack, test flights like this and watching, just to me, watching so many people's hard work come together and come to fruition like this. Love helping to bring this to everyone and share it.
Absolutely. And out in the field, we actually had two crew in the field operating cameras for us to bring y'all different views today. Starting with Pauline Ackelin. This is her camera she had over here. She's not on comms with us, but massive thanks to Pauline for being a part of the broadcast today. And then we also had Mr. Jack Beyer. Jack was actually up on the tower out there at Mojave, providing us this angle here. Let's see as we switch to it. That was the angle from Jack up on the tower out there today. Jack, we still got you on comms?
You sure do. And I just once again want to underscore what a cool day today was. We got to see full retract of all the gear of ROC for the very first time. We got to see it flying clean. And I mean, hey, I'll take a minute since I'm giving my outro here. I got to check a bucket list item off. I got to come up to the top of this tower, which how cool is that? Thank you to Mojave Air and Spaceport for allowing us to film from the top of the tower. And thank you to Mason so much for the idea for putting a camera up here. Absolutely super cool views. And I'm 100% floored. I hope all the test objectives today were accomplished happily. And I'm excited for the next flight with a pylon. Moving on to further the flight envelope of ROC.
Jack, are you excited? I think we can barely tell if you're excited or not.
I'm so excited too. I'm going to go up on that tower with you next time.
It really was a great idea, and it's a great angle of the ROC as it's here on the runway. Like it's stopped in the perfect spot for this shot right here. So,
Mojave, this is the land of flight test. Mojave Airport this is what it is for.
Yep,
it is. It really is. There's so many cool things that have happened here and that will happen here, and I'm just going to take the moment to just gratuitously zoom in because, oh my God, what an angle this is. So cool. Thank you to Stratolaunch and to Mojave Air and Spaceport for allowing us to do this.
Yeah, absolutely. We had a lot of fun as we were sort of waiting for the broadcast to start here this morning. We saw experimental planes going all over the place, and we have all our cameras up even when we're not sharing them with you viewers. So we were well entertained watching all the planes and all the activity there at the Mojave Air and Spaceport. Hey, also a massive thanks to Mr. Michael Baylor. The shot here at the end of the runway, most of the tracking you saw today was automated computer vision tracking that Michael put together himself. I put together a camera for him. We were able to deploy it again with the help of Mojave out there at the end of the runway. And so a lot of those tracking shots you saw were courtesy of Michael Baylor. Don't normally have him on comms here, but I imagine he is super happy with the way some of those shots turned out today, especially when the camera looked up and the ROC was going right over the top of it. That was that automated camera, the robotic camera we placed at the end of the runway. So excellent work today, Michael. That was absolutely fantastic. And lastly here, folks, my name is John Galloway for NASA Spaceflight. You may have heard people talk to me or refer to me as DOS, but I answer to both names here. And that is going to bring us to the end of our coverage. Flight 4, Test Flight 4 for the Stratolaunch ROC back safely on the ground. We'll be standing by for how those tests went and for more information on how Stratolaunch will be progressing with Test Flight 5 and beyond. For now, that is going to mark the end of our broadcast. Massive thanks to all of you for watching here. Also, massive thanks to Stratolaunch for partnering with us and helping us cover some of the costs of making this broadcast happen today. But we are going to go ahead and shut it down, and we will see you nerds later. Thank you so much for joining us.
Propulsion continues to be normal.
RCPT pressure looks good. Following up. Roger, roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight number SE off. Bring in SE off.
Yikes. You bet. Concur. We don't need any more of these.